This is live. This is going on YouTube live, and the link will stay there, so anybody with the link can access it.
Are we live, Suresh?
Just a bit.
Sure.
Yes, we are live.
Yes. So good afternoon, everyone. It's always great to see. It's always great to see folks back for every month's meetup. So I welcome you all to the January edition of the Kubernetes Bangalore meetup. We do this for those of you who are attending this first time. We do this meetup every month. We used to do theme-based meetups before the lockdown and before everything went live. But now virtually, we do a lot of talks focused on Kubernetes and cloud native technologies. So today's session is going to be about Kubernetes 101 session for beginners. So every 3 or 4 months in the past as well, we've done a Kubernetes beginner session for those who have just started to play with Kubernetes or started to work with it professionally, so that it helps the wider community as well, and it brings in more people who know Kubernetes into the community, right? Without much ado, I think we are already running a bit late. So I'll go ahead and introduce our first speaker for today. And before that, I would also like to thank all the speakers for joining us on Saturday on this weekend. So our first speaker for today is Riyaz Walikar. He's a co-founder at Kloudle, which is a Kubernetes and Container Security startup. Right. He and his team primarily work with container orchestration tools and cloud native infra and security. So he's OSCP and CREST certified security evangelist, and he works mainly on the security aspects of cloud native world. So his passion includes enabling security education, and he loves talking about Kubernetes and security. So we have Riyaz amongst us today. So yes, over to you, Riyaz, and thank you for joining us today.
Thanks, Prakash. Hi, folks. Welcome, everyone. I think Prakash added the bit about education, security education, and how I like to talk, about security. Most people who know me personally know that I simply love to talk, right? So let's try and keep it that way for this presentation. What I have here is the introduction to what Kubernetes means for absolute beginners, right? And how do you go about if you've never been introduced to containers or the Kubernetes world? The slides that I have here should serve as a good introduction to all the terms, concepts, right? And why do we actually talk about orchestration, and how does it impact, and how you use these in your production workloads and stuff. The actual meat of today's content is the hands-on session, because I primarily believe in hands-on learning. The presentation will serve as abstract and theoretical concepts, try to clear that, but please make sure that you attend the hands-on the session that is there after this talk, right? That is actually going to enforce the learning that you want to achieve on this Saturday afternoon. All right, so let's get started. Prakash has already introduced me, so I'm just going to skip the this show the slide that I had. All right, let's take a step back and look at what the world was, maybe, I don't know, when 20 years ago. But the concept of when applications started being accessible to folks on the internet, right? Imagine back in the day when you had an internet-facing service, a website that you and I would use perhaps to do shopping or check email, right? The web application required a web server. Okay, and then some of them required a database if there was any user or data driven feature that was involved. Finally, it could be a login or a cart or check your inbox and stuff like that. Web servers and databases are software, right? They have to run on top of
Just a second. Let's let's take a pause. Guys, please ensure that you're on mute all the time, unless you have a question, and we are open to questions. Yeah.
Okay. Yeah, there's no way to selectively unmute people, so Prakash ends up muting me as well. So please, folks, for the because this is a community event, please respect the decorum of the conversations that we're having, the talks that we're having here. Right, most of us are voluntarily doing this, right? So please respect that. All right. I was saying the whole concept of what applications could be and the way they were hosted was very monolithic, the way to look at it, right? And very host dependent, I would say. I don't know if you folks have ever seen the Apple's website in the year 1990, right? This is what it looked like, and this is like a really bad example of how applications would look like on a browser that people barely remember, right? We've come a far way from there, right? We had the host operating system running a web server. It had an app server running. There was storage with extension to our NTFS depending on what OS you were on. There was a network perimeter which had, which was the firewall, which was talking to the internet, right? We moved from there rapidly because of what I would like to call as the developer consumer revolution. Okay, essentially, code started getting modularized, which meant that if there were 10 functions that would do repetitive tasks, you would bundle them all together, right? And then you would import them into a larger file, right? So if you have something that would check for your credentials, for example, you could simply bundle this. If you had something that would move your when you click on a button, animate the page, you could bundle this, right? Code modularization allowed developers to build apps faster. Repositories and pipelines allowed for easy deployment, right? And developers started moving really fast because you could then release, and software cycles became a reality, and this the DevOps revolution started. With the advent of internet reaching everybody's house and mobile devices becoming even smaller, back in the day when my first internet device was super slow. Right now, the mobile phone that I use is at least 30 times faster than my first computer, right? So we've come a far way from there. But essentially, when people started accessing services at a higher frequency, scale became an issue, right? And applications are now being built faster. Underlying infra had to be kept up with, almost an every day deployment sort of thing. And based on how many visitors were accessing the app, scaling and management post-scaling had to be done. Okay. OS virtualization could only scale the hardware requirements, but the app configuration was still the bulkier part. Right? I think that those were exciting times, about 10 years ago when all of this is happening. But the arrival of containers changed that narrative, right? Containers in some way or the other have existed in Unix environments all the way when chroot was introduced in 1979, right? But the mainstream application of isolation of system resources, your CPU, memory, and IO resources, was popularized with Google's process containers, which was eventually merged with the Linux kernel as C groups, right? And then like all mainstream software, stuff has already existed, but there is always this hero who's far more recognized than all the hard work that has been done in the past. Docker became the superstar, right? And in 2013 it popularized and changed the container world, made it easy for people to use and create containers throughout the world. So going back to the question of, and this is relevant from a Kubernetes point of view, because essentially Kubernetes is a container orchestrator, and we'll come to what container orchestrator is, right? We'll try and answer the question of what is a container in an as abstract way as possible. Okay. You will get a hands-on of what these things mean, right? And you'll be able to relate to the concepts that I'm talking about when you do the hands-on later on in the day. Right? A container essentially is a unit of software that packages your dependencies for the application, right? And this runs as quickly as possible, right? As soon as you've created the container once, you can create it and redeploy it multiple times. Essentially, think of this like a mini virtual machine, But in the case, if you've worked with VirtualBox or VMware, you know that sometimes you have to, it takes time to start a new virtual machine. You have to configure a bunch of resources, how much RAM to allot, and other things. But containers are like really tiny mini virtual machines running an operating system like Alpine, for example. And these are built to be run fast because they don't have they don't have libraries that are not relevant to the apps running. Right, a lot of bloatware and a lot of software gets coupled into operating systems when you try and install a new OS, right? uh, Containers don't have all these things, which allows them to quickly start from scratch, if that has to be the case, right? A container runs on top of a host, right, and is created locally on the host based on any pre-created image which are stored on what are called the registries, right? And uh, like passing an instruction to a software, you can pass instructions to the container runtime that, hey, I am going to be starting this container now. I want these specifications for this container. This container should have port 80 open to the world. This container should be able to read my host's particular directory. I'm simply mounting a volume path over there. This container needs to restart if it dies. This container should also be able to allow inbound traffic, for example, right? All of these instructions can be passed either through a configuration file or at runtime to the container runtime itself. A host can have multiple containers running, and each of them can be talking to each other while they're all sharing the CPU and resources of the host machine. Okay. So this is the example of what Docker is, right? So you could have one container running Tomcat Java on a Debian host, the container host itself, and then you have another container with PHP, MySQL, and Ubuntu, and then there's a static binary running on Alpine. All of these are running on top of your host machine, right? All of these containers are sharing the CPU and memory and IO resources of the host operating system. That's what Docker gave us. So the question then arises that what do you do when you want to manage multiple containers, right? For complicated problems, I try to create this scenario where I am living in a 10 people world, right? And then there is the other world where we are with over 7 billion people, right? In an ideal 10 people world, everybody knows everyone, right? So in an ideal 10 people world, a single standalone container is great, right? For testing your code, for hosting, whatever you wanted to do. You can use them for hosting extremely low traffic. There are 9 other people who are going to be requesting data from your container. Imagine my mom's recipe website, for that matter, and I'm hosting this on a container. If your container dies for some reason, one of those 9 people who rely on the recipe website will get in touch with you and ask you, hey, can you restart the container? If I've already configured it to restart, I have no problem. The container will automatically restart, right? If I want to avoid talking to the other 9 people in my 10 people world, I will configure the container to auto restart if it dies. But that's not the case in the world that we live in, right? In the real world, what do you do when you suddenly have to serve like over 1,000 people who are trying to visit your website in the same second, right? Imagine my mom's recipe of butter chicken became super popular because of Reddit. How do you keep track of whether your container is alive or dead, right? Containers can die sometimes, especially if there is memory exhaustion or your configuration is incorrect. If the container will start and will die, you have mounted the volume incorrectly, it can't find the file that it's supposed to host, right? It will start and just die. What do you do in such a case? How do you track those? How do you get the container to start again, but this time with additional memory, right? Imagine I have another 32 GB RAM box sitting next to me, and I'm like, oh, I can use this to serve all those million other customers who are trying to reach, right? How do I, at runtime, use this within my container environment that I have set up, right? What do I have to do if I need to add another route or start a new service or open another port without bringing the application or the current firewall down? How do I ensure, right? How do I ensure connectivity between any new containers that I start, right? Or the world or any other apps that the environment is currently using? There are tons of business use cases that I can't think of, right? But the reality is that container orchestration, if your enterprise is using containers to manage their workloads, you will definitely have use cases that are going to be unique to your company or your work environment. That is where container orchestration comes into play. Okay. So let's try and understand what does the term orchestration mean. Okay. Let's see what is container orchestration. You managing the life cycle of containers is like the single line definition of what container orchestration would be. Like expanding on the definition of what the life cycle of a container would mean. One sec, okay, folks. I'm just getting a lot of things. I'll just disable my screen. Okay. Sorry about that. Right. Changing the state of containers at build or deploy or at runtime, right, based on what is required on a supply and demand sort of thing, right? You would require another additional piece of software that takes care of all these aspects of your containers lifecycle, right? Essentially, orchestration allow you to have deploy your containers, maintain redundancy, scale based on traffic, right? Expose any services that are required, and isolation and security for containers on the same host if required. Kubernetes is the most popular container orchestration software, right? There are others like Docker Swarm, for example, but Kubernetes is, I think, the second largest open source software project right now after the Linux kernel, right? And it has reached that levels of popularity because it has a very strong and active community, who continue to add features, build add-ons that can go into your Kubernetes and do stuff that maybe the native core Kubernetes doesn't provide. It's become really, really popular, right? It's also stylized and written as KTS. Was founded, a little background, was founded by Joe Biden and a bunch of folks at Google, right? And part of it was originally, the concept was originally taken from a software that Google had created for cluster management that was called Borg, right? Based on Star Trek. There's a character, there's actually a whole species of folks in Star Trek called the Borgs. They have a collective hive mindset, right? So it was created based on that reference, right? Original code name was 7, and a piece of trivia: the 7 spokes that you see in the Kubernetes logo is actually based on the name Project 7, right? The character 7 of 9, played by, I forgot her name, the female character. She has a receptor here. That pretty cool series if you haven't watched. Digressing a little. The original Borg project was written entirely in C, but the Kubernetes system was completely rewritten and implemented in Go. Right, released in 2015 of July. Google created the CNCF, the Cloud Native Computing Foundation, offered Kubernetes as the seed technology, one of the first projects that got released under the Cloud Native Computing Foundation. Couple of concepts that we will take a look at now, and you will get a hands-on of this when you do your session later on. Right? Let's take a look at what each of these terms mean as an abstract level as possible, as abstract as possible, and try and see how we can create analogies for stuff that we are already familiar with. Right? Cluster is what we keep hearing when we say Kubernetes. Right? Sometimes people say Kubernetes cluster, or sometimes when people are saying cluster, they actually mean the whole Kubernetes environment that they set up. A cluster is what you get when you set up and run Kubernetes, right? With at least one node running. Okay. And when I say node here, node is a virtual machine that is running inside Kubernetes. And we'll come to what nodes are in the next slide. The term cluster is used to define what the whole of Kubernetes environment is. Okay. So when sometimes says my cluster went down, instead of saying one of my Kubernetes nodes went down, it means that something much worse has happened because their entire Kubernetes infra has gone down. So when they're saying cluster has gone down, for example, right? All cluster objects can be identified and defined in plain text files called YAML, right? Essentially, they use the YAML format to describe the object. And this configuration can be applied to the cluster using, clients that operate and work with Kubernetes systems, right? Kubectl being one of them. For example, I can put an example. For example, if you want to start a new Apache container within KTS inside a pod, I would create a YAML file that describes what the object is, what the Apache pod is supposed to do, and then run a command like kubectl apply with the file apache.yml, right? That contains the description of what the pod should do. So coming to nodes, pods, and containers, a node is a virtual machine on which containers run. right? Within a logical group called pods. Nodes that run the containers are called worker nodes. Okay, these are the terms that you'll keep hearing when you start working with Kubernetes. Every node within the cluster has a container runtime. Obviously, because you have containers, you require a runtime to run the containers, right? Docker being the most popular and one that we've heard and used, right? With version 1.22 in the future, Kubernetes is not going to support Docker being the primary container runtime. You don't have to worry about it because when you deploy Kubernetes, the container runtime is already taken care of, right? And container D will become the default. Kubernetes is actually at, I think, version 1.20 right now, right? And Docker is still supported, but it's deprecated. A worker node has the following components essentially that allow it to maintain the pod lifecycle and allow communication between pods with the nodes, with the cluster, with outside and stuff, right? All of these are processes. These are binaries written in Go that are running on the node itself. You have a kubelet, which is a program running on the node that ensures that all containers within the node, essentially inside pods, are healthy. Right? Kubelets are what are responsible to start and stop or remove containers within pods that have been, based on the instructions that they receive from the control plane. Okay, like me as a user, if I want to start a new pod, I will send an instruction to the control plane. The API server will take care of that, send an instruction to the kubelet, and the kubelet will then either delete or modify or remove or add a new container to the pod. Kubeproxy is responsible for traffic navigation, right? You would want external services to be able to talk to your containers and pods, right? So the kubeproxy is what takes care of any traffic that is coming from outside the cluster or even within the cluster between nodes and between pods. The kubeproxy is responsible for routing that traffic. And the runtime is obviously what we spoke about, Docker being a popular one, is what it actually runs the container. Okay. Containers and workloads essentially they used in exchange with each other. They when people are talking about workloads, they're essentially talking about containers inside a pod, right? When a new container is requested to be created, an image is going to be pulled from a registry. If you specify the registry, great. Otherwise, if you're running a managed Kubernetes cluster, for example, on GKE, it will pull it out from the GCRIO, the Google registry, right? If you specify, you can specify definitely a registry from where you want the image to be pulled. The container is going to be built based on the image that is going to be pulled. A pod is the basic scheduling unit in Kubernetes. A pod is nothing but it's a collection of containers. Usually, there's one container and sometimes two. Right? If you're using what we call is the concept of a sidecar, the pod contains a group of containers, all of which must run within the same node. Okay. Each pod is assigned a unique IP address within the cluster, which is not static. Right, and developers are often advised not to use the IP address of a pod within a cluster for any of their work, and you should create a service that then talks to the pod. Which the service then maintains a table, right, which pod has access or which pod is mapped to what IP address. Because if you restart the pod, if you destroy a pod and recreate it, the IP address can change. You can actually get assigned a new IP address which was already existing for another pod. A pod also knows if a volume was attached to it. You could have a storage or a host volume path mounted in such a way that it was assigned. You can then assign it to the pod so that it becomes accessible to the container within, right? The control plane is what takes care of all your major execution around your Kubernetes system. When you send instructions to the Kubernetes cluster saying, hey, I want a new pod to be created in this particular node, the instruction reaches the control plane, right? And the control plane is then responsible for directing whatever else is required to be done within the Kubernetes cluster. In Kubernetes, multiple hosts work together to give you what the Kubernetes systems, right? A machine, virtual or physical, called the Kubernetes Master, which essentially harbors and hosts all the programs that are responsible for implementing the control plane inside Kubernetes are run on the master, Kubernetes Master. This master receives instructions from tools, right? Clients that essentially interact with the cluster, Kubectl for being one of them, and instructions like, hey, get me a list of all running things within the cluster. The things could be, give me a list of pods, what are your namespaces, right? What services are present, what secrets are. All of these instructions are received by the control plane, right? The master receives it. That's another example that I've put in. to do what the control plane does, right? To do what is required to implement the control plane, the Kubernetes master has the following components running as processes, right? etcd is the primary data store for Kubernetes, right? This is a name value pair system in which configuration data about what's running inside the cluster is stored, right? Including secrets. Secrets are stored in plain text, base 64 encoded technically, which is plain text if for all that matters. Secrets, configuration data, all of these things are stored in the etcd, and this is your data store. We have an API server, which is REST API server, which uses JSON over HTTP and to communicate, right? You can implement authentication on top of this so that only authorized and authenticated users are able to connect to the Kubernetes cluster and use commands to retrieve or change the state of the cluster. The scheduler, this decides which node has enough resources, right? If there's a request for a pod to be created or scaled, right? The scheduler figures out, hey, this node appears to have some 10 GB of RAM free. Let me assign all workloads here. Right? The next 10 pods that are going to be created are going to be inside this node. Right? Basically, a glorified supply and demand coordinator. Right? There is also a single binary called the controller manager, which internally is three different things. Primary of them being the replication controller, which takes care of ensuring that the required number of pods are running, that number of pods that have been declared in the spec when you're creating the cluster or when you're creating the pod, those number of pods are running at all times. If one of the pods dies, it will simply look at the etcd for what the state of the cluster was supposed to be, and then spin another pod. Right? A daemon set controller makes sure that when new nodes are created, there's at least one pod running on it. Okay, and there's a job controller, which is used to work with concepts called jobs in Kubernetes. Essentially, jobs are nothing but pods that have a very specific task that needs to be that has a specified start, and after it completes execution, it ends. It kind of shuts on the pod itself. So the job controller ensures the pod starts, finishes the job, and then the pod is killed at the end of the job completion. A very common concept that you'll come across is the concept of namespaces, and it's one of the first things that you'll interact with when you start doing hands-on, right? Namespaces are non-overlapping isolation that Kubernetes provides, right? That gives you, I wouldn't say physical separation, but some amount of logical separation of resources within a cluster, right? There is communication between namespaces. By default, all namespaces can talk to all namespaces within a cluster. Okay, but simply so that you can implement some level of isolation, at least when you're working with Kubernetes objects, you'll be able to see that there is isolation between the namespaces that you have. Right, you have your default namespace, for example. Whenever you create without specifying a namespace, you have the default namespace. You also have the kube system namespace where all the main Kubernetes components are running, right? The DNS and the controllers. Imagine you have a large environment. We have multiple teams, right? You have devs and testing and other things. You can create namespaces for each one of them. If you're doing this at home for exercise and you're practicing Kubernetes, you can play with namespaces. But it's not very useful when you're trying to work with only a few testing things, right? It becomes useful when you have large environments. A replica set ensures that a specified number of the same pod is always running across the cluster. Right, you can specify the number of replicas you want running at all times, and the replication controller that we saw was part of the control plane. Make sure that those number of replicas are always running. Right, and again, like most objects in Kubernetes, you can describe this in a YAML file and apply, right, to the Kubernetes cluster, so that the cluster takes care of deploying the same number of pods as specified in the replica. A deployment is, in most cases is only the term difference between deployment and replica sets, especially when you start looking at the YAMLs that describe the configurations, right? Deployment is technically used to manage a replica set, right? For example, the replication controller manages the scale. If I have 3 pods running right now, but the replica set has said I need to run 5, 2 more are going to be started, and ensuring that the scale is maintained to 5. But deployments will manage what it happens to the replica set itself, right? Like if I want to add more pods to the cluster, I would have to use a deployment when a replica set is already existing. Okay, you essentially the replica set is redeclared when the deployment is scaled up or down. A daemon set, in a way to explain this, normally Kubernetes decides based on the scheduler what nodes have resources free, and then starts your pods in those nodes, right? For some use cases though, if you want to have one single node running all specific kind of pods, something that for logging, for example, if you want all log monitoring pods to be running inside a particular node, you can use a daemon set. And you can say that, hey, I want for every single node that is started, the daemon set will make sure that at least one pod of a particular type is going to be running inside that node. Okay. Labels and selectors, another very important concept. I learned a little late when I was picking up Kubernetes. You can tag objects inside Kubernetes, and this is extremely useful. Okay, what you tag are using keys called labels, right? And a label selector is the actual query that you'll run against Kubernetes to select those labels. The response to a label selector is going to be the objects that is selected. If you create 5 pods with labels called Apache, right, and if you want to select all of them because you want to either remove them or add more memory or whatever it is you're doing as part of orchestration, you would then select the label selector, right, which will give you the objects that you want to operate on. Services are used to by definition, services in Kubernetes is a set of pods, right? They're working together and they are essentially doing the same thing. You could have an application running on Apache, for example, and all of these are running across multiple pods. So when you want to when you want to describe it as a service, you're going to look at all of those pods doing the same thing as a single unit, right? The service allows the primary concept of why services are created is to allow communication. Right? The service discovery allows for something outside the cluster or something within the cluster itself, but in another node, for example, or a different set of pods and another namespace to appear as a single IP address and a port. Right? So all communication, then the service decides who gets based on the routing, and based on what kind of service, you'll be able to see that traffic comes from behind the service and it occurs to whatever is outside the service as a single unit. Volumes are your file system mounts, essentially, because containers are going to be, the term is ephemeral, right? The idea is that containers, when they start, don't have an understanding of, or rather don't preserve the history and content that is present on the file system inside the container. As we understand, containers are mini virtual machines. They will have their own file system, right? But when you create anything on those file systems, apart from what is declared as part of the image for the containers, nothing else is going to be preserved if you create it on the file system, right? You can't like create your own /home directory inside a container and hope that once the container restarts, the content is going to remain, which is why the concept of volume mounts, essentially providing an external persistent storage that exists for the lifetime of the pod, right? And when the pod dies, the data remains intact on the volume. And this volume can be shared by multiple pods on the same node or across the nodes. To make this more abstract, imagine this as an external USB thumb drive, right? You could plug it to multiple computers. The data on the pen drive is going to remain intact as long as the system doesn't remove the data. Okay. Volumes are mounted at specific mount points so that the containers can read write to those particular mount points based on the permission that is assigned to the volume mount, and then that data can be reused by another pod. Okay. All right. So what next? The concepts that the keywords and concepts that we've covered here in this presentation would work as some sort of at least you would have heard these concepts when you start doing the hands-on session next, right? That's the primitive idea behind the presentation itself. But highly recommend that you revise the presentation or the Kubernetes documentation is extensive, right? While doing the hands-on session after this talk, okay. Although the concepts are covered which are abstract in the presentation, they can, for a lot of folks who are not used to theoretical concepts, can be a deterrent to learning. In which case, obviously, doing the hands-on activity and practicing what you've learned, right, repeatedly, will allow you to retain what you're learning. Okay. There are a bunch of references I've provided at the end of this presentation, right? It's here. Okay. And these are that's my Twitter, my LinkedIn, and my blog, and the company blog, the company website that I'm a co-founder of. All right. That was all that I had to cover in my presentation. Suraj Prakash, want to take over?
Yes. So I think we have a bit more of time. So what we can do is we can take a few questions if that's okay with you, Riyaz.
Sure.
Right. So we'll do this. So in case any one of you have any questions, you can raise your hand. You should see that option, right? So you can raise your hand and ask to unmute so that we can unmute, or you could ask questions in the chat itself, which Riyaz can take. Yeah. Riyaz, there are a few questions coming up in the chat window for you.
Sure. There's a lot of conversation in the chat, so I'm figuring out what, which are questions and which are not there.
Yeah, Prachi, you can unmute yourself, I think.
Yeah. Hi, Riyaz. Prachi here.
Hi, Prachi.
Yeah. So my question is, what is the difference between secrets and config maps? I do confuse with this a lot of times, but I'm not clear.
Suraj Prakash or Ajay or Savita.
Yeah, I can. In fact, we have a hands-on, Prachi. That's one of the last session on how do we leverage secrets. So generally, if you look at it, secrets are a way to store some what do you call it? Temporary or sensitive information, right? So I wouldn't say password because initially Kubernetes created it for storing passwords.
Yeah.
But if let's say the cluster was compromised, you can easily decode that password because it is only #64 encoded, right? But the reason why you will use config map is, for example, if you have heard of config servers, right, where you have to load some property files or you want to dynamically change some properties, then you can leverage config maps. So config maps use plain text for storing key value pairs, but secrets will be encrypted, right? So if let's say you have some token which you are sharing between pods, right, then you can leverage secrets, right? I wouldn't suggest you to use passwords for secret, but Kubernetes generally says you can store sensitive information like passwords or maybe something which you want to encrypt, right? Which can expire after a period of time, right? Something like tokens. Like for example, you authenticate to a service, you create a temporary token, you can create a secret which can be shared with multiple pods within the cluster, right?
Yeah,
so that's
because that's primarily stored inside the cluster itself.
Cluster itself, correct. Yeah, right. Yes, yeah.
Config maps essentially will not, config maps not. I don't think they're used per se to exchange authentication, authorization, or any operation that requires you to have a secret, right? Anything that requires you to verify with the cluster who you are, and I don't think config maps are used for that. So secrets are primarily used to tell the cluster who you are, or tell actually the application who you are. The application then going to store whatever is required, or the cluster for that matter.
Okay, got it. Thanks. And another question is, you just said before about the control plane, right? So control plane is basically the master components?
Yes, the control plane is what is hosted on the master, Kubernetes Master.
Okay, then you said like if you want to change like Kubectl, sorry, which manage the container state, right? So if I want to basically, like you said, the container is healthy or not, starting the container, ending the container. So you said we interact with the kubectl. So suppose I'm interacting with the kubectl, and then it sends the query to the API server, and the API server will send it to Kubectl, right? Is that the sequence or what? like control planes comes for API connector, API server, you said, or like that?
Yes. So the way to interact with Kubernetes is that it provides you what is called an API server, right? So any instructions that you send, if you want to like interact and start a new pod, for example, the cluster, you would use a client like Kubectl or the web dashboard, for example, which will interact with the API server. The API server is then going to query and ask the kubelet, hey, what is the state of your pods right now, of the pods right now in the cluster, and that will retrieve the information, right? And that information again is stored in etcd, okay, at any given time. So that information then formatted into JSON and sent back to the client.
Okay, got it. Cool. Thank you.
Nice.
TJ, if you have a question, we can take one more question before we move on to the next session.
Yeah, thank you. Thank you, Riyaz. My question is, does this Kubernetes usage will differ from cloud to cloud, and how we can understand this?
When you say differ from
AWS, AWS, Azure, and Google Cloud.
Yes. So thank you for the question. So the interesting thing is that Kubernetes as a software, right, can be implemented on various things, and you could have and different companies have created their own versions or variants of Kubernetes, right? Like Rancher has K3s, for example. The concept is that all the fillings of what Kubernetes is, that you have a control plane, you have a client that will interact with the control plane, you have stuff running inside the Kubernetes with their pods and other things. All of this as a structure can be implemented across various clouds also, right? And all the three major cloud providers have done this, and they have services that they host, right, with AWS, AKS for Azure, and GK for Google, right? All of these are managed Kubernetes clusters. When I say managed, the concepts of the cloud environment are also integrated along with the Kubernetes cluster. For example, a very common example that comes up is with the identity and access management part of the cloud, right? So if you have created users within IAM of AWS, for example, you would be able to use those users inside your Kubernetes because there is a cloud controller also present in those managed clusters. Right? So your cloud related concepts, some of them would become applicable to Kubernetes as well, from an interaction between the users and the pod and the cluster perspective. The other important thing is there is the concept of 4 C's in terms of cluster security, right? In terms of any cloud native security for the matter, is your cloud, code, container, and cluster. Right? The cloud bit, the security of the cloud component of a Kubernetes managed cluster is supposed to be taken care by the cloud provider, right? So in case you're running a Kubernetes cluster on-prem, right? If you set up something at home or in your office on a data center, you are responsible for the security of the underlying nodes or the machine on which the nodes are running, okay? But in case of the managed cloud across AWS, GKE, or Azure, the security of the underlying host infrastructure, for example, is responsible. The responsibility lies with the cloud provider themselves, right? So yes, to give a more longish way of answering this, Kubernetes is well integrated across all 3 cloud providers simply because it's another piece of software that these folks have managed to create as a platform. Okay.
So only bit change in the managing pattern, cloud cluster controller,
yes.
These things.
Yes. Managing part and the integration of the cloud components within the Kubernetes cluster. Right, as I said about the authentication authorization.
Yeah, thank you.
No worries.
So I think that brings us to the end of the first session. So first of all, I would like to thank Riyaz. He took time on such an important day for him and was with us on this weekend. Yeah. So
thank you, Prakash.
From all of us, happy anniversary, Riyaz.
Oh, thank you so much.
So thank you for spending this time with us and taking the audience through the introduction of what Kubernetes is, right? And also I would like to apologize to everyone about the few hiccups we had during start, and we are also fighting such spam is something that we are discussing actively right now, and we promise to do better in the future. Also, we appreciate it when we get feedback from the speakers as well as the audience. So it would help if you're there until the end, where we'll throw this open to everyone, and we would love to hear some feedback from you as well at the end on if you have any feedbacks as to how we can do this better or anything for that matter. So since we're running a bit late, I'll quickly introduce our next speaker for today. So our next speaker who will be kickstarting the hands-on sessions is Savita Ashture. So Savita works at Red Hat as a senior software engineer. She has working experience on a lot of things from Kubernetes, Knative, a lot of service meshes. And also she's a current full-time contributor to Tecton CD project. She is a certified Kubernetes administrator and certified Kubernetes application developer as well, and very regularly, delivers talks at a lot of open source conferences and meetups. She's been a regular contributor to our talking at our meetups as well. So welcome, Savita. I'll just put you on stage. Yeah, over to you, Savita.
Hey, thank you, Prakash. Thanks a lot for the brief intro. Thank you, Riyaz. So for the brief explanation about the basic concept, which is very required before starting the hands-on section. So let me quickly share my screen and show the hands-on session on the Katacoda. Do let me know if it is visible.
Yep, we can see it.
Yeah. Okay. So I don't have any specific presentation because we are completely relying on the Katacoda Katacoda documentations. So today, as part of this hands-on section, I will be covering launching a single node cluster for Minikube and deploying a containers using a kubectl command line tool itself, and also to showcase the deploying the containers using the YAMLs. So these are the three basic things I will be covering as part of the hands-on sections. So before that, I hope all of the attendees who have joined, they are ready with their Katacoda sections, and if they are not able to log into the Katacoda, I hope they have running Minikube locally, so it would be easy for them to do a copy paste and run their workload over there. So let's get start with the first scenario, which is launching a single node cluster. So what I'll do, I'll just log into this one. Okay, yeah. So let's start with this. The first thing is like we will see the Minikube version, which is 1.8.1. So this is the basic command to start with, to start the Minikube. So like for example, if you are doing it on our laptop or like any Ubuntu machines, there are options you can specify, like what will be the your CPU, how much CPU want to provide as part of your Minikube virtual machines, and memory, and what will be the VM driver. So those kind of information you can provide if you are starting, if you are using on Minikube on the laptop. Okay, so it takes some time to start the Minikube to launch the Kubernetes. So you can see here a few things like enabling add-ons. So what are these add-ons in the sense like, okay, if you are not using Minikube and if you are using a bare metal, and on top of that, if you are installing a Kubernetes, you need to do lot of things by yourself. I mean, for example, one example I can give is a dashboard. So by default, dashboard will not be enabled, or you can say it will not be installed if you are following kubeadm instructions to deploy multi-clusters on your bare metal. So in that case, those things you need to manually install it. But this is one of the advantage of Minikubes for the local development, where you can get most of the features by inbuilt, and you can enable it with few basic commands. I'll be showing this add-ons part a bit later as part of this hands-on sections. So now we are ready with the now we are ready with the Kubernetes cluster on top of Minikube. So what I can show is like we can use a command called status to see, okay, whether we have ready Minikube, like host is running, API server is running. So it means our cluster is up and running. Okay, then we can see IP also, what will be the IP of this minikube which we have hosted on. Like if someone wants to log into the minikube and check what are the processes running inside that, so we have straight away commands like minikube ssh. Okay, so I think like as I specified while starting the minikube, we can specify the drivers. Like it can be your kvm2 kvm and none. If you specify none, what will happen, this host itself act as a minikube virtual machine. So in that case you cannot do ssh. So it will consider this entirely, this networking it will use as a minikube virtual machines. Now let's continue to the next part. I hope like everyone are ready with the minikube installed. So before moving on, just wanted to make sure that it's up and running. So now let's see the cluster informations. So it shows like, okay, Kubernetes master is running on this IP as, okay, sorry, yeah. So as I showed, like when I specify minikube IP, it showed me like .36 where the actual Kubernetes master is running, and it's a HTTPS connection. So the port is 8443, and kubedns is running on this 8443, and this is the proxy address. Now like, okay, so as I said, like it's a single node cluster. So when I how do I verify, okay, it's a single node or multi node? So we have a command called kubectl get nodes, which will give us the information like, okay, how many nodes we have as part of this. Nodes in the sense you can assume as a VMs, which where the actual components of Kubernetes are installed. So right now we have only one, which we call as a master. Now okay, so now we are ready with our cluster. It's up and running. So our next task would be to deploy our applications and see how it works, and to know like, okay, if it's if it created successfully and if we are able to access and get the result, then we can say, okay, my cluster is working perfectly, there is no issue with the cluster. So to verify that, I'm just going to use a basic kubectl command. I'm not going to use any YAML or hi-fi commands here, just a basic create command. So you can see here, okay. So before that, I just wanted to show like one fundamental basic resource of Kubernetes is a namespace. As Riyaz explained, like namespace is the one which actually maintains the resources access between different you can say different users, so that you can avoid by creating a namespaces and creating resource over there. So right, I'll just quickly show kubectl get ns is the short form for the namespace. So how do we get to know these what are the short forms for different uh, uh, resources? We can have a kubectl help, and we can see these are the different commands available as part of the kubectl. And when we go with when we start using these commands, we will see more sub commands. What are those sub commands provided as part of those main commands? So let's see, like kubectl get namespace. If I do, so by default, whenever there is a Kubernetes installed on a cluster, these are the 4 namespace we usually get to see. Like default, where default is the namespace where anyone can install, and we have one you can say reserve kind of namespace where it is not preferred for the users to create their own resources. So kube system is the namespace where the pods for the Kubernetes control plane, we can say control plane components are actually running. So to see that, if you see kubectl get pods, and if I don't specify name, as I said, by default when I do any get operations, then it will directly make use of default namespace. It will assume, if I don't specify namespace, it assumes, okay, I am doing operations on a default namespace. So if I want to go to other namespace, I need to provide manually that namespace information over here. So this way I can see the information or resources created for that in that particular namespaces. So as Riyaz explained, like in the control plane, we have a control plane components like API server, controller, okay, and etcd and scheduler. So these are the control plane component, and proxy will be there over both master and node. So right now, as we are on single node, we can assume both master and node are on the same machines. So that's why I'm able to see most of them here, even code DNS. And if I want to see, now you can see, ask here like where is kubelet running. So that's actually run as a process. So if I do kubelet, so I can see the kubelet is running as a process, as a binary, you can say. So this way, a single node act as both master and node. You can say single VM. So this is how like all the components are up and running. Now let's just quickly create a applications with a basic command called kubectl create. So what I'll do, see, kubectl create deployment. As we know, like deployment is the basic resource of Kubernetes, which helps us to deploy my applications. So I have this is my applications where I have created an image for that, okay, and I will be giving that image informations while creating a deployment. So what this deployment will, it will create a pod for me using this image, and that pod contains a container. That's what we saw in the introduction sessions, where we got to know about the deployment, how the pods are, what about the pods, and how containers will be running inside a pod. And we also saw that, okay, pod is the basic entity in a Kubernetes world where actual containers will be running. So now what I'll do, so here I have not specified any namespace, right? So my workload should get scheduled, get created on the default namespace, right? So right now what I'll do, kubectl get pods, you can see no resource found in a default namespace. If I don't specify namespace, it will consider as a default namespace. So let me create a deployment for myself. So here I have created a deployment. So now if I do kubectl get pods, you can see a new pod got created, right? Now, like when I create a deployment, how this pods got created is because, see, if I go to this pod and see hyphen o YAML is to get the description of that created pod. So when I go to this pod and see the information, I see there is a one entity called owner references. So this indicates this pod, or you can say this entity is not created directly when I executed this command. So it means for this pod, the owner is someone who created this pod. So you can see here the owner is replica set. Now, like if I go and see what is replica set, this is a short form for the replica set. So this is, I'll just do a get on this replica set. So you can see here the owner reference for this replica set would be deployment. And if you remember, like while creating, I have directly mentioned deployment. So now if you just recover what in the last session what Riyaz explained, like deployment is the object which actually help us to create replica set and which internally manages the pods. So this pod will be managed by replica set, and replica set will be managed by deployment. So this way parent child relationship will continue. And so if you remember, like as Riyaz explained, the deployment is the resources which helps us to do control the life cycle of a pod with the help of replicas. So I'll just quickly explain that part. If you see here in the deployment, the replica section, right? So I'll just quickly clear my screen and show the deployment object. Let's take the first deployment as the name and do hyphen o YAML. So I can see here for this deployment, there is no owner reference. it means it's the basic, it's the one which got created, and with that, with this help of, with this all other resources got created. Now you can see here there is a field called replicas. So as we saw in the theoretical explanation, replicas is the entity. With the help of replicas, we can increase or decrease the number of pods which we wanted to run. So right now, like when we initially just created with the basic command called kubectl create deployment, it will always create a pod, just single pod, and specify the basic default value as replicas as 1, right? And next we saw also the explanation about the selectors, labels, right? And the spec part. So I'll explain this. What about this? What are the different parts, attributes we can specify as part of the spec, and how this selector and label relationship works a bit later in the session. So now this is how the basic kubectl create command works with this flow. Now if I, as we already saw, kubectl get pods will give me the running pod informations. Now what I'll do, I will expose this. Okay, now just pod got created. I want to access these applications. Otherwise I will not get to know, like whatever I have written in my application, whether that's actually working. So to make sure that that actually working, what I'll do, I'll just hit, I will access the applications and see whether whatever information I want as part of my application is getting or not. So to do that, we have a object called service. So with that service, what it will do, it will map the pod endpoint to the service, so that we can, when we hit the service object, it knows where, it knows to which pod it should contact. Okay, so now I'll just quickly expose this pod deployment. So when I do kubectl expose deployment, it will get create service for me. So you can see first deployment, the if you see the age part, you will get to know, like, okay, it's one which is recently got created. Okay, now how one thing we need to understand here is, if I give just deployment, how this when I access this service, how this service will get to know, like it should go and reach to that particular deployment. Who will handle that relationship between the deployment and the service? So before that, I'll just quickly show, like if how to access this service and get to know, like whether my application is working perfectly. So what I'll do, as part of this, so they are getting the port from this service, right? So what they are doing, they are doing a kubectl get service and getting the node port out of that. So the port I will get is 30803, which is this one. Okay, where the traffic from internal container port, it is redirecting to the node port. And when I do curl this host, I'll be getting the response back from that applications. Now you will be now we all have like lot of nouns here, like what are these node ports, what are this port, and what are this service type, and etc. So before that, I'll just quickly show how the relationship works. Then I will just quickly explain this service part with these different types. Okay, so let me get the service object in detail. So this is my service, right? Service hyphen o YAML, right? Okay, so kind service, you can see label and selector, right? So okay, before that, can I open a new terminal here? Yes. Okay, it takes some time, so meanwhile I'll show here itself. So just observe one point here, there is a selector attribute in the service, right? So this same app first deployment should present in our deployment also. So I will quickly do a get on the deployment to see what will be my labels over there. So you can see here, yeah, label is first app first deployment which is same like this selector. So this relationship, label selector relationship will actually do helps in the communication between this deployment to the service. So, and also one more thing here I want to show is kubectl get endpoints. So you can see here, okay, kubectl, one more thing is pods hyphen. So these commands will be get hands-on when we start practicing with the with lot of examples. Then these commands will be very handy. Otherwise, for the initial time, it will be a bit difficult to understand like what are so many commands with kubectl. But no worries about that. It will be handy once you start exploring with the kubectl commands. So you can see here, when I do kubectl get pods, it will show the pod IP would be IP will be 172.18.04, right? So and when I do kubectl get service, describe service and first deployment, sorry, describe. See here, when we created this service, this endpoint got created. So it means when we create this service with the help of label selector interactions, what this service do? This service creates a endpoint object, and it will add the actual pod endpoint IP inside the endpoints. So this way, this service, when we hit this service, when we call this service, it knows like to whom it should contact, to which pod it should contact by using this endpoints which are present here, right? Now one more, okay, this is how the label selector works. Now second thing is like we saw a lot of about this type, right? So by default with the service we will be having a 3 types: four: node port, cluster IP, load balancer, and external IP. So by default, if we don't specify anything, it will take type as a cluster IP. Now, like I want to node port is the one where it node port helps us to access my applications with the help of node IP. So what this node port with if we specify node port in the service, what it will do, it will expose one dynamic port across your nodes. So this access across the clusters. But if I want to access my cluster externally, in that case, what I'll do, I'll make use of type load balancer. So these are the few types of services which helps us to access my applications. This is how service and pod relation works. Next is, okay, so before going to the add-ons, if any doubts, please let me know like through in the pod and deployment section and service. Okay, I assume no doubts. So let me enable the dashboard. Okay, so before that, if I see Minikube add-ons list, so these are the add-ons which Minikube by default supports. And when we when we start Minikube, by default this storage class and storage provisions are enabled, and remaining things are in the disabled state. Now what I'll do, I just want to run the dashboard so that I can see a wonderful UI of the Kubernetes. So what I'll do, I have a handy commands with the Minikube called Minikube add-ons enable dashboard. Right, so this has enabled the dashboard, and I can see kubectl get pods in the this namespace, which is Kubernetes dashboard. It has not installed on the kube system namespace, right? So it's up and running. Now, now I just want to see whether it created any service for me, right? So see, service. It created a service, but the problem is it has not exposed the port. So now I'll show the use case of the service of cluster type. So if I do -o YAML, I see this type as cluster IP and there is no port. So with this service, I cannot access my dashboard, right? Because this has not exposed on the node also or externally also. If I want to access this dashboard, I should be on another port where that pod IP I should be able to reach. So to avoid this situation, what I'll do, I will quickly apply this YAML where a new service is creating with the type as node port. So I'll quickly show the op Kubernetes dashboard YAML. So you can see here in this namespace, it is creating a new service called Kubernetes dashboard Katacoda, and the selector is still same, KTS app Kubernetes dashboard. So it means for one pod we can create a services, but to make sure that my service should reach to that pod, I should make sure very carefully with the selector part, right? So this KTS app Kubernetes dashboard, it is a selector for the Kubernetes dashboard pod. Now I will quickly apply this YAML and I see SVC. Okay, sorry. So, okay, Kubernetes, yeah, unchanged, kubectl get SVC -n. Okay, let me see in which namespace it got created. So yeah, namespace is Kubernetes dashboard. So let me do a quick get on that. Okay, see, it got created Kubernetes dashboard Katacoda and it has exposed on 3000 ports. So here, this is the URL which I can access, and we can easily see the nice UI of Kubernetes where we can see multiple pods in the visualization way. I think it is, yeah. So this is how it shows. So we can walk through different namespace. If I go to Kubernetes dashboard, I can select which workloads I want to see. So this is how it looks. This is the end of this launching single node Kubernetes cluster and deploying a simple basic applications. So next scenario would be now like we saw launching a minikube cluster and deploying through kubectl command. So this deploy container using kubectl. Okay, I think I crossed the limit or what. Let me sign into the GitHub and see. Yeah. Okay, so start scenario. Yeah. So as part of this one, again, what they are doing, they are starting the minikube. Because whenever we switch from one session to the another session on the Katacoda, that entire cluster, entire minikube will be down. So we need to start it again to work on that particular session. So it takes again bit time to start it. So meanwhile it starts, I just wanted to cover, like before starting this scenario, we had one more like multi-cluster part. So there what they're doing, they are making use of KubeADM tool and they are deploying the multi-cluster Kubernetes. That means they will have one master and multiple nodes. So there we can actually visualize what are the control plane components which actually runs on the master, and what are the node components like kubelet, kube proxy, add-ons as part of the node sections. Now, okay, so the minikube is up and running. So again, I'll just quickly do a kubectl get nodes. It shows one node. Okay, so now like this is again this exam as part of this scenario, what are we going to cover is we are exploring new command of kubectl to deploy my applications, right? Still it is through kubectl command line itself. So I will be making use of kubectl run here to deploy my applications. So you may be thinking like what's the difference between kubectl run and kubectl create? Why are we have so many different options to deploy my workloads, right? So it depends on ease of usage and the flexibility of use cases, right? So if I just want to try out a simple applications to immediately, like without having any extra configurations to be provided, like for example we saw in the previous hands-on, like kubectl create, we just give name and the image, right? But we don't have over there with the kubectl create command, we don't have any other options to give, like hyphen replicas. These information I cannot specify as part of the create command, right? So to make sure that like what are the options available as part of the create, we can do this way, and we can see how I can make use of this create command. And another difference is with create, it is not only allowed to create a deployment, but there are a lot of things I can do with the create command, right? I mean, I can create a namespace, config map, secret roles, everything. It is a general create command which helps us to do. And even we can specify the YAML file entirely to create an object, right? So this is one thing. But with the help of run, yeah, so now let's create a pod with another command called run. So kubectl run, still now it I mean there is earlier it used to support deployment apps also, we can directly create pod also, but it's going to be deprecated soon. So with the run we can just create a pod, okay, or job, or I can make use of kubectl create to create a deployment. So let me quickly get the deployments here. Yeah, it's ready. And if I do describe, same like it has all these spec sections, and it gives the one basic information like, okay, how many pods are up. One of one means one pod. We have specified replicas as one, and you can see here replicas one desired. Total we have specified as one, so one is available. So this the one of the functionality of the this deployment is to make sure that always the provided replicas are up and running. If it is for any reason, if it is down, then what will happen, we will this the responsibility of this deployment controller is to make sure that to run this replicas run this number of replicas provided here to be up and running. Now let's go to the next thing where, see, now what I'll do, this is how I can, with the run command I have created a deployment, right? Again, we have not created any svc, if you remember, right? So this is the one which comes by default with the minikube. Now to create svc for the like for this pod, what I need to do, again I need to kubectl expose and deployment. So we have another flexibility with run with this expose is like okay, yeah, again we need to make use of this expose command to deploy a application, I mean to access the applications. So here you can see we are making use of this external IP instead of node port, right? So if we specify this external IP, it means I can make use of this IP to access my applications. So it means I can on this external IP, actually my service is able to forward the request to particular pod. And if I see the service here, HTTP is the created one. Sorry, yeah, HTTP -o YAML. Here the external IP is here, even though type is cluster IP and we don't have any node port. So this external IP, what it will do, it will it will bind this. Okay, it will bind this port which is 8000 on this external IP. Now, okay, I forgot to explain about this part, which is port and protocol target port. So one thing we need to remember is this port is something specific to the service, and this target port is something specific to the container. So this target port indicates that my container is running on 80. So whenever there is a request to this service, which is on, which will come on port 8000, which get to know, okay, if request coming to 8000 port, it should redirect to this 80 port where the actual container is running. So this is what this meaning of this port and target port. Now let's continue with the next thing, which is, till now we need to do two commands to create, one command for the creating the deployment and another command to expose that deployment as a service, right? Now we have flexibility with the run command to expose, to create a deployment also and to expose as a service also, right? So I can make use of this one, kubectl run HTTP again expose, and this is the name of the deployment. This is a image, and I have specified replicas as 1, and the port is 80. So here one thing we need to see here is host port, right? So till now we saw node port, node port, load balancer, node port, target port, and port, but we didn't come to this host port section at all. So what does this host port, right? Okay, so before that, kubectl get ports. So this is the HTTP exposed is the one which got created now, right? And kubectl get svc, if I do, I don't see any service which got created when I do kubectl run, right? This is because this host port is the one, what it will do, it will not create us any service, but instead it will directly bind that port to the pod itself, right? So you can see that like you can see the explanation over here, like you should able to access through this one. Under the cover, this exposes the pod via docker port mapping, right? As a result, we will not able to see this using kubectl get svc. So this is because we have a pause containers. What are these pause containers in means? So for every, when we run a pod, there will be along with our in the pod, along with our main containers, which is specified through this image, we will have a pause containers. Those actually handles this networking solution, networking parts. I mean, which actually manages this networking and across that entire pod as an interface for that particular pod. Like for example, in that pod, so whenever there is a deployment created a pod, it actually gets a single IP, right? So how that single IP based on the pod, it how that single IP will be shared between multiple containers in the pod. So in a pod we can have multiple pods, right? It doesn't mean that for one pod we should always have a single container. No, we can have multiple containers within the same pod, but how that one IP will be shared across among all those containers is something where pause containers comes into picture, where it actually manages those network bind to that same network interface. uh, this is how this host port works. Now one more thing, it's not given here, I just wanted to try out. So instead of giving the host port, what I'll do, I'll give another name. Sorry, yeah, another name, and image will be same, replicas will be 1 and port will be 1. I'll give node port. Node port. I hope I'm giving the proper name. Okay, let me try with this one. Okay, it says unknown port. Okay. So in that case, if you don't know what will be the node, how we can give different informations, what we can do a help, and we can traverse here whether that particular things are available as part of this command, right? So here we can see multiple ways how we can expose, how we can make use of labels, how we can make use of image, and how we can specify this replicas command. So all this information we can specify as while executing this run command. I don't think whether we have node port as part of this. So let me quickly traverse here. Okay, I think it is not provided. So this expose will be used for that. Okay, let me do a grep. Okay, so it is not there. Okay, so only we can able to make use of this exposing. Okay, so this particularly this kubectl run helps us to expose this service if we specify the port as host port. It means a port will be available directly on the pod, not through any of the services directly. So this is the use case of this run. We can directly expose over there. Next, okay, you can see here we have lot of commands over here. I mean, we can specify labels also, selectors labels we can specify. So this way we can control like, okay, what are the labels I want to provide as part of my deployments while creating the deployment. Otherwise, by default, it takes by specifying name key as the app, and name will be whatever name we will provide while running the command. So next part would be, yeah, scale the containers. No, like one way I can specify through replicas, like how many number of pods I want to run. The other way would be I can make use of this kubectl scale command and specify the how many replicas I can specify here. So if I give replicas as 3 and do get pods, you can see the remaining 2 pods will be creating now, right? And if I do kubectl describe svc, earlier if there was one pod, in the endpoint section you used to see only one endpoint, right? Now if I scale this pod, scale this deployment with 3 replicas, it means 3 pod got created, and in the endpoint section I should be able to see 3 endpoints, which and each of have a different IP address. So it means this particular service is able to manage those 3 different pods, and whenever there is a request to that service, the request can go to any of these endpoints. It's not necessary that request always goes to this pod, and this pod. It can go to any of these pods. So when I do curl request, so it may go to this or this. It's a round robin fashion by default. Okay, so we are completed as part of this. So the next scenario would be, till now we saw deployment of applications with the help of kubectl command. Now let's make use of YAML file to deploy the workloads. So before that, okay, now I will just quickly show how this YAML looks and what are the attributes will be present as part of this YAML. Till now we just saw like with the help of kubectl command and with different commands, how we can create a service, how we can create a pod, deployment, and replica set. Now how we can write a YAML and what are those things present in the YAML, right? So actually I would have been covered this in the initial stage, but it would be difficult to understand like, okay, if we have a kubectl, then why can't we make use of commands to create the pod itself? So that's why I just went through the flow. Like first, I just shown like with the kubectl what are the different options available to create a pod deployment and services. Now we will make sure that how we can make use of YAMLs to create the same things, right? Now I can see API version. So whenever we write YAML, every YAML will have these 4 sections, which are API version, kind, metadata, and spec. So this API version indicates the stability of these resources, right? So this apps v1, okay. So this v1 before in Kubernetes, any object before moving to v1 stage, it will be in different state, like v1 alpha 1, v1 alpha, v1 beta 1, v1 beta. It depends on the use case of that particular resource, how much is important in the Kubernetes world, kind of thing. So when it reaches to v1, it means this this resource is available as a GA. Like it won't be deprecated now, kind of thing. But if it is in alpha or beta, there will be possibility that that particular object may go into deprecation lifecycle. So this API version indicates that part. Then coming to kind. So this kind indicates what are the resources. So if we say pod, the kind will be pod. If we say service, the kind will be service. If we say deployment, then this kind indicates what is that particular object. And in the metadata section, we can specify name of that name of that particular object, and it will have labels also in this metadata sections. Next, coming to spec, right? So this spec is the spec is nothing but the how this resource, or you can say object, should look like. What are the attributes we can specify when we declare this object? So in the deployment, we have, these are the basic things required to declare this deployment object. So this spec is the actual body where we will specify how this deployment looks like, right? So here replicas is a field which shows, okay, how many number of pods I want to make sure it runs when it created. Next, it will have a selector, right? See, this selector means, as we saw in the previous two sessions, like, okay, when I create deployment, it created a replica set and service, right? So as I just gave a brief over there, like this selector is used to match with the labels. So based on the labels, what it will do, it will control those resources. It controls the pods. How it get to know? This deployment, when it specify replicas as 1, how this make sure that this pod is up and running, and it always watching to the right pod. There can be multiple number of pods running on the cluster, where each may have the same selectors, right? So it always matches this selector and label funda, and make sure that it have the desired number of replicas pointing to this particular deployment. So this selector will be used for that. Next, when we create this deployment, we will have pod created, right? So where are we giving that pod information, like what is the image, what will be the env for that, what will be the container port for that containers? So those information will be, and what will be the name of the uh, pod, we can say, right? So those kind of information we can specify over here. So this entire this template section is there, right? This template section describes the how my pod looks like, right? So here also we will have a spec, where this spec indicates contains the information of container information, like this containers is an array where we can specify multiple containers. So this way deployment can handle multiple uh, uh, in a single pod, multiple containers. So that information will be provided as part of this spec, as this containers is an array. Now here, this is nothing but name of the container, okay, and the image, and this is the container port. These are the basic required things needed to create my application. Here, along with this information, I can specify the health checks, I can specify env, argument, commands, whichever required based on the use case. So this is how the simple deployment looks like. But if we go with the complex use case and complex scenario, this YAML will change entirely. But keeping things like these are the basic necessary things required for every deployment. After this, whatever extra things we will specify, that depends on our particular use cases. So now let's copy to the editor. So it has copied to the deployment.yaml. Now what I'll do, I will just create a deployment. So deployment got created. Let me do the get on the deployment. So it shows, okay, one replicas is available. Now again, if we do the describe on the deployment. So here, few things I wanted to show. We just gave name, right? Namespace also we didn't give. So if we don't specify namespace for any of the create object, it will consider default as a namespace. So this is the something which is added by Kubernetes itself whenever it creates an object, right? So here, if you see here, we didn't specify any labels as part of this metadata, right? So that's why it shows as a none. And annotations, this is something which is added by controller itself, I mean deployment controller itself, to indicates, okay, this is the object which is created for the first time. So whenever there is a change in this deployment, this value will change to indicates, okay, how many times it got updated. Now you can see selector, right? So this is the one which we have specified here in the YAML, app web1, okay? And the replicas which we have specified here, which is 1. So it shows, okay, 1 is the desired, 1 got updated, and total is 1. And 1 is available. So if there is any issue with your pod, I mean like some issue with the pod container, so if it start recreating that, so this value will keep on fluctuating. Like this unavailable section will have some pod numbers which indicates, okay, there is some issue with my application. Now strategy type, which is rolling update. As we have not given any information about the strategy type, so default it will take as a rolling update. Now what is this strategy type? Okay, so before that, I just briefly tell uh, about this strategy type. So we have multiple controllers, right? We have deployment, we have job, we have replication controller, we have replica sets. So all for all the work of all these objects is to create a pod at the end. But why this deployment is most useful, popular, and which solves most of our use case? One advantage of making use of this is this strategy type. I mean rollout mechanisms. So with this rolling update, what will happen when I do a update? Like for example, I just created my deployment with this image, right? So later if I want to do update to my deployment, I'll do go here, update this image, and I'll reapply it, right? So when I reapply by changing the image, what it will do, it needs to terminate the current running pod, and it should make run the other new pod, right? So in that case, when it start terminating and it make it to another container to be in the running state, so there will be a gap between them. I mean so when so that gap will be something handled by this strategy type. So it makes sure that until the new pod is comes into running state, if we if we start sending the request to my pod, the old pod actually serves the request. So with this strategy types, it makes sure that until the new pods come into running state, the old pod won't go into terminating state. So this way we can make sure that 100% availability of my pod on a cluster. So this scenario actually comes into role when we actually work with the production kind of environment, where the environment is live, where multiple request comes in a milliseconds. So in those kind of things, it will be very useful, this rolling update strategy type. Now see, you can see here pod template, right? So pod template is nothing but this template which we just saw. Like this actually contains, this is the actually template which will be used by the pod to create it, right? So what all information we have specified, we have given the label, and in the container section we have specified port and image, right? Remaining things we just kept as it is. So if you remember, in the last section we have specified while running the pod, while executing kubectl run, we have specified host port, right? So if you give something host port, it will be added over here. If you don't specify, it will be empty. And as we have not specified any environment, it will be empty, and there are no volumes mounted here. So it's a simple basic deployment which shows. And these conditions shows what are the events it's got stored while executing, like whether a minimum replicas is available, I mean the status of the deployment it shows, and replica set information also it will have, and it will show whether that is the success, I mean healthy or not kind of informations, right? Next, what I'll do, I'll just click on continue, and we'll go to the service section here. So as we saw in the previous hands-on, like how the service looks like and what are the uh, attributes of the service. So again, I just want to focus here. API version indicates the stability of this object, and kind indicates which object we are going to create, which is service. And as I said, every YAML in the Kubernetes will have this format. I mean, the template would look like API version, kind, metadata, and spec. This is how the we can say like standard template for the entire Kubernetes objects. So here again I can specify name, labels, and this spec indicates the actual type, I mean actual the attributes of the service, where we can specify what will be the type and what are the ports we wanted to make use, and what will be the selector, so that it can go and reach to this particular uh, uh, pod. So you can see here selector, sorry, labels as app web app 1, and here I need to specify selector, so that this pod, this service based on this selector label match, this service will get to know, okay, I should go and reach to this pod. Now let me copy this YAML to the editor. It got saved. So before that, let me clear this one and create a service, right? Yeah, I'll do a get service. So you can see it got exposed on the node port. Now if I do describe service, we can see what are the information which we have given and what are the default things it took by itself. Now when I do curl request, I'll get the information. Okay, next. Now, okay, till now we are doing with the single replicas. Now I want to update my replicas to more than one. One way what I can do, I can go here, update it, and I do a kubectl apply, right? Another way what I can do is I can edit the running deployment. So we have get deploy is this one, right? So what I'll do, I'll copy this, do edit operations. We have edit also, and I can specify web app 1, right? Now it opens the editor. Over there, I can change this replicas value, and if I save it, it creates the applications. Okay. Now what I'll do, instead of that way, first I will show with this. If I give 2, now it got saved. If I do kubectl get pods, 2 pods should be up and running, right? And if I do kubectl get svc, this is the svc, right? So I'll describe on service, so that to make sure both pods are pointing to the service. Okay, describe. Yeah, so you can see endpoints, both pod endpoints are pointing here. So to make sure those are the proper endpoints, what I'll do, I can do wide. With this option, I will get to know, okay, what are these pod IPs, and we can see here. This is one way. What I'll do now, we will edit this replica. Okay, no, this is something local copy of the deployment, right? Till I just change in the runtime, right? Okay, let me show you kubectl get deploy. So you see here, I just done a edit at the runtime, not through local copy. So because of that, my local copy still have the replicas value as 1 itself. Okay, you can see in my web app, deploy. Currently, I did a runtime addition to the deployment, and I see 2 pods are up and running. Now, if I give 2, it will not do any effect because 2 are already running, so it doesn't care. Now, what I'll make it to 3. So when I give 3, what it will happen? When I do apply, it should create. You can see here, to make sure 2 are ready, but we wanted 3, right? So right now available is 2, but the replicas given is 3. So this deployment controller gets into activation state and start creating 3 pods for us. So kubectl get pods, you can see 3 pods are up and running. And to make sure that when I specify 3, it has not terminated all the existing pod and recreated, we can see age section here. So you see here, this is the one which got created recently, 22 second, and 2 minute is the one which we edited during at runtime, and 10 minute is the one where it got created in the initial state when we initially applied the YAML. So this is how we can create the workloads with the YAML, with the kubectl commands, and we can do operations on the running objects during runtime or through the YAML. So these are the different ways we can make use of kubectl commands to deploy our workloads. The next thing, yeah, I think I have finished these 3 parts. Next, Ajay will be continuing with how we can make use of one sample example of Guestbook, and he will walk through over there, and he will give brief about few of the fields of deployments like networking section, Ingress, Liveness, and all those things. Thank you. Any questions? Please feel free to ask here.
Yes. So thank you so much, Savita. Thank you so much for kicking off this session. And I'm sure the audience got a lot of basics from your sessions, right? So also wanted to say that, for 5 minutes, we will be taking a break right now. So if you have a question, you can, raise your hand. I can unmute you and we can have a question answer session as well during the break. So we will reconvene at around 3:55 for Ajay's session as well, right? So please raise your hand and I can unmute you, and you can ask your question. Yeah. TJ.
Yeah, thank you, Savita, for great insights. The question here is regarding the certification. I heard you are certified on Kubernetes, but for that certification, do we need any requisite certification or pre-knowledge?
Okay, so before that, which certification you want to do, CKA or CKAD?
Which would be the basic one?
Okay, so it depends on like your involvement and your day-to-day work, which one you want to take. So actually CK is the one which covers entire cluster related concepts and the administration level concept, and where CKAD will be actually relevant to the developer perspective. So it depends on like which area you are interested. So if you want to give concentration towards the administration area, then go for CKA part. So where you want to know, where you will be knowing lot about the cluster management, how this master node communications will happen, and how these components will be deployed. So those kind of things will be there as part of CK, along with this basic concept of deployment service and how they connect each other, and how these pods or deployment will be scheduled on different nodes, how we can make sure that one node to upgrade and one node to downgrade. So those kind of things will be you will learn when you take a CK session, I mean examination. For
Okay. And do we
CKAD,
need any? Yeah, sir.
yeah.
Yeah.
So for CKAD, it basically covers the development area like networking, okay, and how to develop, I mean, deploy your application with the different sections like pod security policy. So basically, it covers entirely development area. So which actually involves the understanding of each and everything about your deployment YAMLs, you can say, on interactions of different pods.
Okay. And do we need any prior knowledge before going to certification, like anything on AWS certifications or something like that?
No, it is not required. If you just follow kats.io, right? So the standard one, like kats.io. So here if we just focus on concepts and tasks, this concept, task, getting started, and references. So most of the things will be covered over there, like how cluster setup, cluster management, maintenance, and the basic things. So everything will be covered here. Okay, to answer your questions, we don't need any prior experience on AWS and all. Even with a fresher, or we can say beginner, I can start learn with hands-on experience. We can able to do it.
And it's a hands-on exam, right, TJ? So
Yeah.
you will be, you can open one tab, right? You can open
Yeah.
kubernetes.io only, right? And you can get to know all the YAML from there. You can copy paste it in the exam. You don't have to remember anything as such, but the commands are something which you can remember, right? To make it faster. The only thing is the speed in the exam, right? There will be only 19 questions. It's all completely hands-on, right? There is no yes or no type of answer, like how you have it in AWS or Azure, right? You won't have like
Okay.
that. So it's a complete hands-on exam. It's like your practical lab which you would have done in your college, right? You only
Okay.
one statement will be there, and you have to do. If the output comes, then it is fine, right? That's how it'll be. It's the same thing here as well.
Okay.
So, so in one word, if you want to say, it's like hands-on experience. How much ever you practice, that much your speed will increase, and your knowledge. Look, where and all you need to search and find out the answers. So practice is required more.
Okay.
I think we have a few more questions. I think we can take one or two more and then keep the other questions for the end.
Yeah.
Yeah.
Hi, Savita. Prachi here. Thanks for the amazing session. Yeah. So I have a question. If I want to access a service using Notepad, so how can I access this? Like I know using the service name and the namespace, then colon Notepad. This is the one way to access. And is there is another way? Like I'm not sure what all other ways are there to access.
So your question is like if your service type is Notepad and how you want to access it. That's
Y-
what your question, if I understand
Yeah,
correctly.
yeah.
Okay, so as we said, like Notepad is the one way which actually make your applications access across the cluster. I mean,
Mm-hmm.
if you have a cluster where you have a three nodes, okay, and
Mm-hmm.
all the three nodes you can able to access, right? So
Mm-hmm.
when we make your service type as a Notepad, it means that particular Notepad will be available across all the three nodes, including master. So
Mm-hmm.
this way, if you just give IP of any of the node or master and the node port, you can able to access your application.
Oh, any of the nodes IP.
Yes, any of the node IP. That's what this is one thing. Like if you specify node port, that same port you cannot use again in that particular cluster. So that's one thing we need to remember. Yeah.
Means every application should have a separate notebook. You are saying
Yes,
you should not
exactly.
speak.
Yeah.
Okay.
Exactly. So that's why like we ask Kubernetes itself to handle dynamically. I mean, we will not. There are two ways we can manually provide which node port I want my application to be listen on. I mean, service, like I can specify 3000 to something range is there, or like we ask Kubernetes controller itself to manage that node port. So dynamically it allocates every time whenever you specify. Just type as node port.
I see.
So
I
this
see.
way you will not have this conflict on the node ports.
Okay. Yeah. When you explained the YAML, I saw there was an endpoint which is the pod IP, right?
Yes.
And the other there was another IP like with cluster IP, I believe. So Notepad should also have a cluster IP, right?
Yeah.
Uh, Yes.
Yeah, you
Like,
will be able to access it via cluster IP. The only thing is node port you will be using only when you want to use via cluster IP,
Cluster.
right? But if you want to expose it like load balancer, then you cannot use node port,
Yeah.
right? So
yeah. So what's the difference between node port and the load balancer then? Like,
yeah, I'll explain. Actually, there is a session separately on that, right? Networking. So I'll
uh,
explain them
uh,
in detail. It's going to
uh,
come maybe in few minutes.
sure. No
Yeah,
problem.
yeah, yeah. Cool.
Thank you. Yeah.
Yeah, Rajesh and Vaibhavi and Giridhar, sorry to say this, but in the interest of time, can we have your questions at the end? Thank you. So yes, thank you so much, Savita, for that amazing session, and I hope you all got 5 minutes of break. So since we are already running late, I'll hand it off to Ajay right after his introduction. So Ajay, yeah, I've known Ajay for a while, and he, anytime we need him to, help us out with a few talks or anything, he's always like, yes, can do, I'll do it, don't worry. So Ajay's been a constant, and he's a multi-cloud hands-on architect and has more than a decade of experience in building, distributed systems. He's a AWS community builder, and also he contributes to the developer community via his YouTube channel as well, called Tech Primers. I'm sure he will let you know about that as well. You can follow him over there as well. So at present, Ajay works with Fidelity Investments as a principal architect. So that's a short introduction of Ajay. Ajay, please do cover
Sure.
if I've left something. And over to you, Ajay.
Sure. Thank you. I presume like if you can see my screen, right? Right. So like
Yes, Ajay.
Prakash mentioned, so you can call me Ajay. So if you want to know about my social networking, LinkedIn, everything is present in about.me/moving to web. Like he mentioned, I'm a multi-cloud architect. So I have certifications on Azure, AWS, and Kubernetes. So I work on all these platforms in my free time and also at work, right? Not necessarily just at work. I'm also a community builder for AWS. Recently, AWS started a program called AWS Community Builder. So I'm part of that as well. So I do have engagement with Amazon people, right? So I started a YouTube channel called Tech Primers 4 years ago. It has around 85,000 subscribers now. It just started off as a hobby, and then I just started creating a lot of hands-on videos. And then recently last year, when I started coming out for meetups, that's when I met Prakash and the whole group, right? So that's how it all started. So if you're interested, just take a look at Tech Primers, right? I mean, these are all recorded videos, and then I'm presuming some of you would have come from the channel as well, right? So that's about myself, right? So this should have been the first slide, but yeah, unfortunately I just presented now. But this is some of the uh, things which we look at, right? I mean, if you forgot to mute your mic, it's similar to how you do a reply all in your email and then get exposed to everybody in your too, right? And also this is just a funny meme. Most of the time we think we look good in the picture, but then in the Zoom meeting video we don't look good, right? And that's why most of us don't show up video, right? But yeah, just a funny thing to create a icebreaker, right? So coming straight into the agenda, before looking at what I will be covering, I'll just brief about Kubernetes, right? The Kubernetes architecture. I presume most of us are waiting for the architecture to see as a diagrammatic format, right? Like Riyaz mentioned, right? In Kubernetes, we call group of machines or the complete deployment as a cluster, right? And that's what is called as a Kubernetes cluster. So this is similar to how you call what do you call group of machines, or maybe a data center or whatever, right? I mean, you don't have to call data center here, but in Kubernetes the whole deployment or management is called a cluster. So within a cluster you can have multiple machines. You can have, here we call them nodes, and there is one central machine which is called the master, right? In a production kind of a setup we have multiple masters in the background, but just for reference I put only one master here, right? Generally it comes with 1, 3 and 5 master nodes. And within a master we have different microservices. Again, Kubernetes follows microservices pattern in their deployment. So Kubernetes is like a software which you will deploy in your environment, right? And within the master node we have something called API server, API server will be exposed to the external world. From your kubectl command line interface, you can get all the commands into the API server. There is something called HCD. HCD is the database, which is a key value store similar to Redis, but it's a homegrown database which was built by the Kubernetes team, right? Which is also again open source. So it's a key value store, right? It's an object store. You can use it for use it separately as well, right? So that's what HCD is. Again, HCD will be deployed in 3 different masters. They will have replications and things like that, right? Now, any command you give to the API server will be stored in HCD. For example, Prachi was asking about what happens in the background, right? When I, let's say, do a kubectl create command, the command comes to the API server, and the API server interacts and pushes it into the HCD and stores it, right? Now, the API server doesn't instruct others directly, right? Instead, the scheduler will look at the HCD and then see, do I have anything to schedule, right? Now, when we gave the create command, API server doesn't do directly. API server will put it into the HCD. Scheduler will pick it from the HCD saying, okay, I need to create something. And then it will instruct the controller manager. So controller manager is the guy who will interact with all the nodes, right? Now, how does it interact? There's something called kubelet, which will be installed in all the nodes. And that will be sending information to the controller manager, and that will control all the information within the cluster, right? So if you say any command, the command is going through all the different microservices. It's not like one process which is taking care of your deployment, but it's multiple hops which is happening within the deployment, and all these are asynchronous, right? The synchronous part is the API server storing it into the HCD, and scheduler will take it from the HCD, give it to the control manager. Control manager will see which machine is free, and then it will deploy in that particular machine. Okay, that's what happens. That is about master. Now coming to the nodes, within a node we have something called kubelet. Kubelet is like an agent, right, which will be running in that particular node, which will have a keep alive signal which will be sent to the controller saying these many machines are free, these are the, I mean, these many memory are free, this is the state of the worker node, and things like that. And controller manager will know which all workers are alive based on it. For example, here this gray box denotes that this machine is out of sync or this machine is down, right? Just for reference, I just put. So in that case, controller manager will not get any information from this kubelet. So that is how the controller manager will know this node is down. Okay. Now the next component is the Docker engine itself, right? The Docker engine is responsible for running your whole container, right? You need a container runtime to run your images, right? Images are nothing but artifacts. Here we are using Docker, but again, you would have seen notifications in the community saying Kubernetes is trying to remove Docker and have a separate engine. Yes, it can be any container runtime. Here we're just using Docker for now, right? I mean, it doesn't depend on Docker alone, right? You just need a container runtime to run your images, and that's what this particular microservice is. There is something called kubeproxy, which will proxy all your requests coming into your pod. If there is a HTTP request coming in, it will come via the kubeproxy. Anything which is coming into this particular application or in this particular node will be coming through this proxy, right? And you can leverage this proxy for monitoring, logging, metrics collection, and things like that, right? This is just a proxy which will just get it and then push the data. You can also instruct it to do something using service mesh, but we're not going to cover that in this video. But yeah, just know that it's just proxying all your requests into the node. Okay. Now coming to this diagram, right? The green boxes are nothing but the deployments. So the deployments are where your applications are logically grouped, right? So imagine you have a pod. So pod is nothing but collection of containers. Let's say I'm deploying one particular application which is a container, then pods are nothing but multiple containers, or maybe it's just a collection of containers, and deployment is collection of pods, right? When for example, Savita was showing us about replica sets, right? When you have multiple instances of the application, they are called as replicas. In AWS terms, these are called as autoscalers, right? I mean, when you have autoscaling enabled, here we call it replicas, right? That's the reference. Now deployments can have multiple pods in it, and that's what is called replicas. So this green one is a deployment where I have an application which is called app1, and this is the label I have, right? Now how do I expose this application to the external world outside the cluster? That's when we will use something called service. So service is a separate, service is not just this service, but service is a separate resource type or an object. You can even call it like a REST object or something, because when you want to expose a HTTP endpoint outside, that's when you will use a service, right? And that's what I have mentioned here. So service is a constitution of a REST and also a load balancer, which can do domain lookup as well, right? Why load balancer? Because when you have multiple deployments running, the IP addresses might change, right? Because it can run on 01, it can run on 02, it can run on 03 machines. The IP addresses can keep on changing, right? Now, how do we expose a single common IP address? And that's where service comes into picture, right? So service can act as a load balancer to load balance your pods or your deployments within the cluster, right? So that's why we need to have service also, we need to have deployment also. Even if you're deploying a hello world, you will need to deploy a service separately, right? And that's what this service means. Now, how do the service interact with the pod? And that's where the labels come into picture, right? If you see this label app1 is referenced here, and that's how the labels are mapped. So this is what Savita also showed, right? And that's what we saw, right? That's how service can link with the deployment, right? I presume like you understood the basics. See, if you understand whatever I just showed, whatever I just covered, I think most of your job is done, right? Why do we need a service? We need a service to load balance and access your application. And within the application, we call it deployment, and you have replica sets within it so that you can have multiple instances of the application. Okay. With that, I think what we'll be doing is I'll just give a brief on what all I will be covering, and then we will jump deep into it. First, we will be deploying a guest book application, a web application into the Kubernetes cluster. Next, we will look at what is networking constructs in Kubernetes. These networking constructs will cover the node port, the target port, the external name, etc., right? Load balancer, etc., which is specific to service. I'll cover all those as a part of networking. Next, we will cover something called Ingress. So we will leverage Ingress for routing, right? On why do we need Ingress? I also have a separate slide for it, and then we will cover that. Then we will look at something called Liveness and Readiness Healthchecks. These are required when you want to create production-ready applications inside Kubernetes, right? And that's where we will look at readiness and liveness. And finally, we will look at secrets. How do I store sensitive information within Kubernetes, and how can I access it within the application? Okay, these are the things which we are going to see. For the first example, right, we will be deploying a guest workbook application. I'll just explain what is there in that example, right? There is going to be one application which is called as a front-end application, okay, which will be written in PHP. There is going to be a backend object store which is based on Redis. Okay, we are going to access the front-end application, and front-end application is going to access the Redis application, and the Redis is going to have and the front end is going to have multiple instances, and this is where we will have replica sets, right? We will have 3 instances. Now, since we scaled the front end, our backend also needs to be scaled, because I don't know how long the backend will withstand, right? So we are going to scale our backend to 2 worker nodes as well. So we will be having a front end with 3 instances, and the backend is going to be a Redis deployment, which has a master, and there'll be multiple worker nodes. Okay, we are going to use service to expose the front end so that we can access it externally, and also to access the Redis, we will be using service, right? And this is what we are going to do in this lab. Okay, any doubts till now? Before I see the lab, I can look at some. How do I look at the chat? Okay, chat is here. Fine. Meanwhile, let me go to the lab, right? Let me open the lab. Cool, no doubts. Awesome. So whatever I just showed here, this is the architecture what we are going to do, right? We will be deploying a Redis master, we'll be deploying Redis worker nodes, and we'll be deploying front end. We'll be exposing a service to external world, and that's what we are going to do here. So all these are predefined. If you see, these are all the YAMLs which we require. The first step is to launch the cluster, so I'm just going to launch it. These are just pre-Healthchecks commands to see if the cluster is ready, right? And just for people who are asking about how the exam will be, right? The exam will be something exactly like this. The questions will be in the left side and the terminal will be in the right side, right? This is how the whole exam format of CKAD or CKA will be, right? So don't worry about it. So if you followed Katakoda and then if you tried, it's almost similar, just that we have answers here, right? Now going to the next step is setting up the Redis master, right? This part. That's what we're going to do. I mean, all the commands are already here. I will just open up the master so that we can see the configuration. I've created it. Let's open up the file just to see what is inside, right? Redis team has created a Docker image which we can leverage for deploying Redis, and we are using that particular image here. So this line number 18 defines the image of Redis instance which we are going to use, which is 3.0.7 Alpine, and there is a port which we need to expose. So for Redis, we have a dedicated port which is 6379, and that's what we are exposing within the container. So when we say kubectl, let me do a clear kubectl get pod, you can see that there is a pod which is running, and from this pod you will have like containers within the pod, right? And there's only one container. So you need to expose a port, and this is the port which we need to expose, which is 6379, and that's how we are going to access the application. All these are like predefined, right? I mean, we don't have to worry. It's just called Redis Master. That's it. Okay. So if you look at it here, there are line number 8, there is something called replicas, and this is what the replica denotes, right? How many instances of my master I'm going to run. Here, like I said, we are going to run only one instance of the master, but we are going to have 2 worker nodes or slave nodes, right? So I think we are ready now with the first step. Now the other thing is, how do I access the master, right? In order to access the master, I need to have this service created. This orange box here denotes a service. So I created a pod, which is my master, but how will I access it? I cannot access it directly. So I need to create a service. So in order to create a service, there is a separate YAML for it. So let me open that YAML. This is the service YAML, and I'll apply it, right? See, the moment you click on it, the command gets copied and then entered, right? I mean, it's one of the most laziest tools I've ever seen, but it just does this job, right? But I would suggest you to type the commands and then know it better. That way you know how to type it faster, right? So coming to the service, within the service, we have only these information. So what we're saying here is, my application is running on port 6379, and expose that port on the same port, right? So the target port of my application is 6379, and expose that port to the external world. And the name of my service is going to be Redis Master. So how do I check this service? You can do kubectl get service. There is also a shortcut. Instead of service, you can just type svc, right? So if you don't see the YAML files, I think you can try refreshing it, TJ, right? I mean, see if that works. Now, when I do a kubectl get service, you can see that the port is mentioned here. So whatever port we have mentioned is mentioned here, right? And that's the port we'll be exposing it to the external world. And since this is a cluster IP, right? If you see, I did not mention anything called as type here, right? So by default, it will be cluster IP. So what does it mean by cluster IP? Anybody within the cluster can access this application using this IP address. Okay, so anybody within, for example, the front-end application, which is within the cluster, can access our Redis service using this cluster IP address. Okay, that's what it means. Okay, and we are using the port 6379. And how did we do the port mapping? Using the target port, which denotes the application port, and that's how we are configuring it. Okay. So you can also do a kubectl describe to see what is the IP address. You can directly get it. Okay, so that's what is the previous step. The next step is to set up the slave pods. So the slaves are basically the worker nodes, right? We need to configure the slaves. Now for slaves, there is a separate controller. Let's look at that, and I'll also click this so that it applies. So for slave, if you look at it, there is a separate image, right? This is not the same image which we saw in the master, because slaves need to understand that they are slaves or they are workers, right? So in order to leverage that, there is a separate custom image which is built and pushed into Google samples, and we are leveraging it. Okay, so the container is mentioned here, and also the host names. So if you look at it, there is a parameter called DNS, right? How does the service or how does the slave or the worker node know which is the master, right? And that's how these will know. So get host from will be exposing the DNS, and then we'll be exposing the IP address, which is the cluster IP address. So if you remember, we created a cluster IP address with the service, right, for the master. That will be exposed to the service, to the slaves. So slaves also will use this orange service. Okay, so that's how the slaves are configured. Let's look at the slaves if they got created. Kubectl get pods. So you have 2 different worker nodes, then there is a master. So we are all set up, right? So this part is done now. Okay, any doubts till now? So in services, in service YAML, other than the endpoint IP, there is another IP address which is service IP. What it does in the service YAML, other than the service endpoint, where is that? Do you mean in the slave nodes, Prachi? How did we pass the master Redis IP to the slave? So this was the parameter. If you go to the step 4, there was this where is the controller here, get host from, right? And then there is a DNS. So the value DNS by default, if you see here, if your cluster config does not include a DNS service, then instead you need to access the environment variable. So the value of DNS by default has the IP addresses and the environments, right? I mean, the host name will be injected using the DNS. Since we already have a DNS service within this cluster, it knows that, right? And this is how we are injecting it. Okay. So is service a process on the host or another container? Oh, that's a very good question. If you look at my architecture, right, the service is another container completely. If you look at this, it's a completely different container. The only thing is we don't have control over it. So only Kubernetes has control over it. It's similar to how we have our application, but Kubernetes will have it deployed. And how did we do it? You can just do kubectl get service, and it will show all the services which are there. By default, there will be one called Kubernetes, which is the default one, but the one which I created is Kubernetes Master. Okay. So going to the next one. So the next one is creating a slave service, right? We created the slave pods, but how do I expose that as a service, right? I need to expose it. So I'm going to create the YAML. Let me open that YAML service YAML. So if you see here, here again, we are exporting the same port, right? Since these are separate pods, now who will expose these pods to the external world? We need to expose it again, right? So that's why we did that. Okay. So let me do a kubectl get service. This should show now two things. One is master, the other one is slave. So they have separate cluster IP and they have different ports. If you see, sorry, same ports. Right? How are they able to achieve the same ports? Because their cluster IP is completely different. The cluster IP is a virtual IP address which is specific within the cluster. Okay. So with that, our backend is done. Now we need to deploy our front end, right? So in order to deploy the front end, there is a front end controller.yaml. Let's look at that. And meanwhile, I will create it. It got created. Let me open it. So in the front end container, we have 3 replicas, right? Like I showed in the diagram here, we have 3 replicas for the front end. We also need to create a service also. That's what we're going to do. So we will create a front end. The front end code is present in again Google samples. There is a GB front end which is version 3. And again, how do I know the Redis IP address? How do I know? How does the front end knows the Redis IP address? It's all injected using the DNS construct, right? All the values and the environment variables, these are all injected from the DNS, right? There is a service called DNS, the core DNS service, which will do that for us. Okay, I think you have the link from Nabarun, so you can follow that. Okay, and also the whole front end is exposing the port 80, right? Now this port needs to be exposed in the service also. So let's look at the pods if the front end got created. So see that there are 3 different pods now, right? So some of you had a doubt, right? What is a pod and what is a deployment? Now, if you look at the pods have a different naming convention, right? It has something called front end, and then it has a unique name, right? But if you do a kubectl deployment, you will have the kubectl get deploy. Okay, so it's a we have a replication controller, right? So we will do kubectl get a replication controller. Array. I'll show it from the beginning. Kubectl get rc, kubectl get pod. So the reason why deployment or the replication controller is created is, if you see here, this we are giving a name as front end only, but the pods have a unique name. If I kill this particular pod, right? If I do a kill on this particular pod, it automatically gets recreated with a different alphanumeric, right? And all these are like tagged as a separate replication controller. Now, how does it automatically scale, or how does it automatically create a new instance? And that's where the replicas or the replication controller helps, right? Where it will maintain the state of the application. In the sense, if there are 3 instances of the application which needs to run, 3 will be running. If one goes down, the other one will automatically be created. Okay, and that's why pods have a unique name. If you look at it, right, all the pods are having the unique name, and the replication controllers are having their own names. All right, so that's how deployment and or deployments or the replication controllers work with the pods. Okay, with that, let's go to the next step. So the next step is to expose this application, right? We created a front end, but we did not create a service for it. If I do a kubectl get service, we need to expose that front end into the external world, right? We need to access this front end, right? So we need to create a service again. So for that, let's look at that service YAML. So the service YAML says expose this particular application in a type called node port, right? So why node port? Because I want to expose it in a dedicated port. So if I have an application which is deployed within Kubernetes and I want to use a dedicated port to be exposed, then I will use something called node port. Okay, and I'm hard coding my port number as 30,080, right? And there's another parameter called 40, right? This is nothing but my application which is running on 80, which I am mapping it into something called node port. Now what happens under the hood is this particular front end application within the container will be running on 80 port number, but when it is exposing in the service, here it will be creating a port called 30,080. So if I overlay this with the I think I don't have the diagram here. So if I overlay with this diagram, with this architecture diagram here, right? Here my application will be running port number 80. My service will be communicating with 80 port number, but when I am exposing it to the external world, or when I am exposing it to the internal applications using the cluster IP, here I will use the port number 30,080, right? And that's what we are doing here. Okay, so it got created. Let's look at kubectl get service, and you can see that mapping here. See this, right? My front end application is of type node port. So if you have a unique type, that will be defined in this particular column called type, and here we have something called node port. The IP address for this particular front end is specific to the cluster IP, which is only this IP. So if I want to access front end, I have to access this within this particular, with this IP address only, which will be understandable only within this particular IP, within this cluster, right? And I'm exposing it via the port 30,080, and there is a mapping to 80. Okay, so that's how it works. Now how can I access my application? We can access it using this URL. So in Katacoda, what they have done is they have exposed a way for you to access this node port from the external world. So if you go to step number 8, I can access it directly using this particular URL here. So if I click this URL, it should take me to the application which we deployed. Okay, so if I type hi, if you have this URL, right, I will paste this URL in the chat. Try accessing this URL. You should also see whatever messages I'm typing. All right, because we are storing it in the Redis cluster, right? We are storing the message in the Redis as a backend. So all the data is just retrieved from Redis and it is showing up for you, and it's externally showing up via this particular IP address which Katacoda has exposed for us. And there is a node mapping here, node port mapping. If you see here, right, the URL has like 30,080 and things like that, right? If I refresh it also, it should not go, right? The message should come up. See, somebody has said hello Ajay, hi buddy. You can put your name also, I can read it. But yeah, so this is a sample application which we just deployed, right? So this is how you can deploy a application within Kubernetes and how you can expose it. See, even if you deploy a hello world, you saw how many things you have to expose, right? It's not just the pod, or it's not just the deployment. You have to create something called service, and that you need to expose it to the external world. Okay, so that's how you can expose an application. So any doubts till now? Any questions you guys have before we go to the next one? Correct. Yeah, Ramesh. We don't expose the servers externally. That is why we created something called cluster IP, right? I mean, by default, we created a cluster IP. For front-end application, we created a node port, but for Redis, we created a default one which said cluster IP, right? And that's why we did not expose it outside. It's like putting it in your private subnet in AWS, right? It's exactly similar. What is the difference between port and the target port? Port is the application specific port, right? Target port is something which is defined in the service, which is specific to the service, which will be a mapping between your application port and the port you're going to connect to, right? And that's what it is. In fact, it's almost the same, right? I mean, whatever target port you define in service is the same port number as your application port, right? I will cover that in the next networking again, right? I mean, if you see the next, these are the ones which I'm going to cover now, right? Cluster IP, target port, node port, external IP, and load balancer. These are the ones which I'm going to cover now. So can we use cluster IP to access the application within the cluster? Correct. So within the cluster, you can use a cluster IP, but outside the cluster, you cannot use the cluster IP, right? If you look at this architecture diagram, right? If I want to have a cross cluster communication, In a production kind of a scenario, we might not be deploying our application within one cluster or one region, right? You might be deploying it into multiple regions, right? So in that case, cluster IP will work only within that cluster. So you will have to explore some other option instead of cluster IP, which I will just tell you in a bit, right? Any other questions? What is the load balancer in this architecture? So load balancer, if you look at it, Kubernetes has its own load balancer within the application. You can obviously call service as a load balancer, but the service will do load balancing within a particular type of pods only, right? You can also leverage something called Ingress, which can also do load balancing, but all these will be within the cluster, right? If I have a cluster which is deployed in a Mumbai region, let's say you're using Amazon EKS, okay? I have a cluster which is created in Mumbai region, but I also want to have a DR cluster, which is let's say in Hong Kong or Singapore, right? Now that load balancing will not automatically do across, right? You will have to integrate our load balancer into an external load balancer like ELB or something, right, within AWS, so that you can do cross region or cross cluster load balancing, right? So within Kubernetes, you will have like REST. You can call it like a load balancer, but it doesn't do real load balancing, but it will just load balance within your application, right, within your pods. Okay. Any other question, or I will just start explaining these. If we will be using cloud manager available, like yeah, so we don't have control over those, Ramesh, right? If you're let's say you're using EKS, right? If you're using EKS, Amazon will provide its own control plane, right? In that case, we don't have direct what do you call control with the controller manager, right? But your cloud provider will be plugged into those, right? Let's say you are deploying Kubernetes within your own on-prem system kind of a thing, then you can have a plug between your controller manager to your systems, right? That you can definitely do. Okay. Now coming to the networking topics, right? I'll just start explaining and then you can just post any questions and then we'll see. Okay. I think one question I missed. Shubhendra is asking, in Redis slave YAML, you mentioned that the DNS for connecting, but there will be multiple things running, front end, Redis master, Postgres. How does Kubernetes identify that the YAML wants its pod to connect to the discover master? Kubernetes YAML wants to connect. I didn't get it quite, but I think I got what you're saying. So how does it know which one to connect, right? So if you remember, we had something called labels, right? In the YAML, there is something called labels. You can use the labels to say group all these together and then call it as a service, right? And labels are the key way for matching different pods and then grouping them as service, because IP address keeps on changing, right? Labels are the only way for them to group them, right? Now, how do I access Redis from front end? You have to leverage cluster IP. In this case, we configured cluster IP, so you have to leverage cluster IP. We had the DNS service within the cluster, so we leveraged that. Okay, so that's how we did it. Now coming to the networking constructs, right? The first one is cluster IP. So like I said, cluster IP is the IP address which is defined within your cluster, right? Which you can leverage only within the cluster. So within this cluster, you can use it, right? For communicating within your microservice. For example, app 2 wants to communicate with app 1. How does it do? It needs to use service, right? In this case, I will use the cluster IP. For example, let's assume cluster IP is this, right? From app 2, I will use this IP address to connect to this application, right? And that's how I will be using, right? That's what is cluster IP. So if you want to use within the cluster, you will be leveraging cluster IP for it. Now, what is target port? Target port is the port number which you will be mapping from your service to the application. So let's say the application is exposing 8080, right? Here you will define target port as 8080 and the exposing port as 8081, right? And that's how you'll be mapping these two, right? If you know, now the external guy will see only 8081, right? But internally you will be targeting that 8081 port to 80 port. So if you see the earlier example which we did, right, in I think I closed it, but in the earlier example we mapped the application to 30,080, right? And there was a specific target port, right? And that's what is the target port. We'll be seeing that hands-on in this particular networking introduction scenario, but yeah, that's what target port is. The next one is node port. So node port is where I want to have a dedicated port number which nobody else wants should be using it, right? Because what happens within a Kubernetes environment is there will be only a specific number of ports available, right? Let's take this as a node. There will be only 8080 will be available only once within this node, right? I won't have 8080 again in this node, right? So you won't have the same port exposed. Instead, there will be virtual ports which will be mapped to a different port number within, right? Now, how do I, what do you call, restrict my Kubernetes to say always use the same port number which I instruct you to. That's when you will be using node port, right? And that node port will be defined in your service, right? In this, so your application will be, let's say, exposing 8080. You cannot use the same 8080 because again Kubernetes might be blocking 8080 already, right? Or some other application might be blocking 8080. That's why node ports usually start with 30,000, right? 30,000, mostly the ports are dedicated for application. So you use 30,080 for mapping 30,080 with 80. So external people will only use 30,000. External people in the sense other applications will use only 30,080 in that case. Okay. Have the same target port number everywhere. Can use one. Yeah, see, it can be used only on one node, like Suraj just mentioned, right? I mean, you can use only one once the port, right? If I'm exposing it from this particular node, then I cannot reuse it in this node. I can reuse it from another node. So the IP address will keep changing, right? And if I exhausted that limit, right, I cannot create, right? That's what happens. Okay. The next one is external IP address. External IP address is just a way for us to access our application from external world. Like how we accessed this app, right? The Guestbook app. This particular lookup will have an IP address, right? That is the public IP address which is exposed, right? That is nothing but the external IP address. We don't define anywhere external IP address. It will be just defined as a parameter in the kubectl in the service. I will show that in a bit, but it's just a what do you call public IP address, nothing else, right? And finally, load balancer. So load balancer is what most of us will be using when we want to expose that particular API or an endpoint to an external world outside the cluster, right? If I want to expose it outside, I will leverage something called load balancer. So instead of node port or cluster IP, I will put something called load balancer that will be externally exposed, right? In platforms like Azure or AWS or Google Cloud, the load balancer will be plugged with the cloud platform's load balancer, like Google Cloud's load balancer or ALB, etc. Right? That's how it will be configured. Okay. So that's all I had for networking. Now, if I want you to remember some easy way of remembering these terms, right? This is how you can. You can say cluster IP as within the cluster, target port as port mapping, node port as specific port, external IP as public IP, load balancer as integrate with the load balancer, right? I mean, cloud specific load balancer. So if you remember this particular kind of a table, it'll be easy for you to remember what each of these define or denote, right? Any doubts still now before we start the hands-on? So to kick off the hands-on, you can go to this section called networking introduction, and all these scenarios are there, right? All the scenarios which I mentioned, we are going to go through. Meanwhile, just hit some questions if you have anything, and I'll walk through the hands-on. Is that fine, or am I too fast or something? Or just let me know your feedback so that I can work on it while we are on the session. Because if it was a in-person event, I can just generally look at people's faces and identify if I'm too fast or something. Since it's digital, it's difficult to understand, right? What you guys are going through. But yeah, cool. My application came up, right? It's good to understand. Thank you, Sri. Okay, cool. So the first thing is we need to deploy a service, right? Here, see here, right? There is a YAML. Let's open that YAML and then see what is there inside before even we create it, right? So this YAML says it's of type service. So there is a service, right? And the service name is going to be something. There is a label for it, and we are exposing the port 80. Notice that there is no type mentioned here. When there's no type mentioned, by default it will be creating cluster IP from here, right? So this is cluster IP. It is exporting a port 80. There is also something which is missing, which is target port, right? So target port is not I mean, if nobody mentions, if somebody mentions target port, it will map it. If we don't mention the target port, it will map 8080 to the 8080, right? I mean, it just maps 80 to the corresponding target port of the application, which is also 80, right? And this application, it has two replicas. So we are going to deploy an application and its service, which is a cluster IP, right? And that's what this does. Meanwhile, I think somebody had a question. Sudhakar had a question, right? What is the difference between a public IP and a load balancer? So again, there's no difference. Public IP is just the IP address. If you look at kubectl get service, So there is this external IP, right? This IP address will be populated only when the load balancer is connected to an external load balancer, right? That's when it will expose an external IP address, or else it will expose an internal IP address, right? But most of the time we will be exposing it as an it will be plugged to a load balancer like ALB or Google Cloud Load Balancer if you are in the cloud platform, right? Or let's say you are deploying it in on-prem, you'll be connecting it to an on-prem load balancer, right? Like Nginx or something, right? Or Apache load balancer, whichever you have, right? So external IP or public address is just the IP address whatever we resolve to, right? Whatever this application can resolve to. Right now, if you look at it, this application cannot be accessed from outside, right? Because there is no external IP address. You can access it only within the cluster, which is the cluster IP address, and only within this terminal I can access it, right? And that's how it is. Okay, cool. Thank you for the feedback. Thank you, Prachi. Okay, cool. We saw that I hope you understood the cluster IP, right? Now, in order to access this cluster IP, I cannot access it from the external world. So I'm going to access it using some curl commands, right? There is this curl command. If you see, it's big, but don't worry, it's nothing fancy, right? What they are doing is they are doing a kubectl get command and identifying what is the IP address and then just putting it in the cluster IP. So if I just do an echo of cluster IP, it is just the IP address which just got hard coded. Okay, nothing big. So that's what is happening here. So see that the external, this is the IP address which we got, and then instead of just doing curl hard coding this IP address, it's just retrieving it and storing it in this variable called cluster IP, and from that cluster IP we are doing a curl. Okay, that's what we are doing. And when we did a curl, what it says is this request was processed by the host, and this host is nothing but the pod name. Now, how do I check the pod name? Kubectl get pod should show the pod name. See this, right? Every time I access the curl, it accesses, it responds from a different pod, right? Because I have two pods running. I have two instances running. See this, right? It came from FCDP. Earlier, it came from different pod. So these are the two pods. So in this step, what we did is we used cluster IP, which is accessible only within this cluster. Since this terminal is within the cluster itself, we can access it using cluster IP, and we leveraged the service, which is this service. Okay, and the port is 80. That's how we are able to access the application. So this is what cluster IP is. Okay, I presume like you understood it. The next one is target port. Right now you were asking about target port. What is target port? Right now let's create the application and let's look at the YAML file. So if we see here, there is this port mentioned, right, which is target port. So target port is nothing but I want to expose my application in 8080, but my application is running on only 80. So this target port and the container port should be equal always, right? So this is basically a mapping, right? You're mapping your port number 8080 with 80. So my application is running only on 80, but I'm externally exposing it as 8080. Right, that's what is target port, as simple as that, right? The other things I think you guys are aware of. So target port is basically the port which my application is running, and I want to expose the same port or do I want to change it to a different port, and that's what these two are. Okay, so the target port is same as the container port, and I'm exposing my application as 8080, which is a different port number. Since I did not mention any type here, it is called cluster IP. Okay, so let's see what got created. Now, if I do kubectl get service, we should be able to see that cluster IP got created, and we created 8080. Right now, I can access my application using 8080 itself. Now we can do that here. So see that I can access my application using 8080. Earlier we did it using 80. Now we are doing it using 8080 because we add a different port mapping, which is 8080. Okay, that's what is target port. So are this configuration of the service in relation to the cluster? Yeah, so this is specific to the cluster, right? If you look at the service, it's specific to cluster because we are in the cluster and we are applying it within the cluster. So how do I know which cluster I'm connected to? You can generally do a kubectl get context or get current context. You can also see they get nodes. I think I don't know what will it return if I do current context. I forgot the command though. There's no resource type. See, the thing is, I am inside the term. I am inside the master itself here, right? So I'm directly in the master, so I can directly use the master and then do it. But generally, you can use the kubectl and then connect it. But yeah, how can we access on both ports, or it's like port forwarding? Yeah, it is like port forwarding, right? You cannot access it on both the ports. It's just port forwarding, TJ. You're right. Good. I hope you guys now understood what is target port, right? Yeah. So Kubectl config current hyphen context. This should have returned the current. Yeah. So this is the current context, right? If you see, Kubernetes admin is the current context where we are running, right? Since I'm in this admin machine or the master machine itself, it's showing this. But if you're connected to a separate cloud instance or something, it will show that particular current context right from there. But yeah, so that's how the context will change, Maranza. Any doubts till now before we go into node port? Cool. So node port is like I mentioned earlier, node port is where you want to specifically expose a port number. Let's look at that using this YAML. I just created the configuration, but let's look at the YAML. Now comparing to the older example, right? In the earlier example, we used something called target port here, right? Here we are exposing something called node port. The moment you mention target port, the target port should be same as your container port. But the moment you mention node port, you can expose it greater than 30,000, right? And you have to define this type as node port, or else we will get an error. If I remove this type and then apply, I will get an error, right? Because I cannot assign a node port without a type port. The moment I say node port, I have to define the node port number which I want to expose my application on. So this particular application deployment is running on 80 port number, but I am doing a port forwarding on the node port 30,080. Okay, in the earlier example, we had 8080, right? Internally, Kubernetes will use its own mapping, right? It can sometimes application will be on 80, sometimes application will be on different port, right? But with node port, it will expose this 30,080 on individual nodes, right? And that is why it's different from the target port. Okay, let's create it. So Vijay is saying as each container is a separate context, we can deploy apps on the same port. Correct. We can deploy apps on the same port, but when you're exposing that application to the external world using service, you cannot use the same port, right? And that's where you will be using it. So let's do a get service. So if you see here in the service, we created a node port, and this is how it is mapped. Right, your 30,000. Now, if I create a new service with the same port, I won't be able to. 30,080 is already allocated, so I won't be able to. And since this is a single master with single node, I won't be able to use the same port. Okay, so how do I access this particular application? I can directly use this IP address. See that? So my application is accessible. So kubectl get pods should show my node port application. So node port application is where these two, right? And these two are showing up. Okay, so that's node port. And this IP address, whatever you see here, is nothing but the node's IP address, right? And see that that's what is mentioned here. We can the service can now be reachable via node's IP address on the node port defined. So we are directly using the node IP address and then reaching it with this port. Yeah. Can we have two node port on the single node? No, we cannot. Right? I mean, once the 30,080 is locked, you cannot use it. But if you look at it, when we are in cloud and when we are creating scalable applications, we should not worry about port much, right? Unless or until we use it only for a dedicated channel to channel communication, or when you want to create high latency application, that's when you will use a dedicated port. Otherwise, we don't use a dedicated port as such, right? When you are exposing some HTTP kinds of endpoints, you will be leveraging only load balancers port numbers, right? You won't be expecting the application port. So application can run on any port. Container will use whatever port you have, but then you will have port mapping there, and then it does, right? So that's the thing. Yeah, correct. So it redirects 30,080 to 80, Arun. So within a pod, multiple containers can have the same port. Within a pod, yeah, because individual containers can have their own port, right? But within a pod, I don't think you can. Within a pod, you cannot, right? Because you pods share the same IP address range, right? I mean, so your ports also will be within the pod. You cannot use it within the pod, though they are separate pods. Yeah, so Savita is saying yes. No, you cannot use it. Correct. What else? Is there a way to give domain name rather than? Yes, you can do. So that is where you can use something called external name. You can leverage external name. You can also leverage Ingress for it to have a domain name instead of IP address and port number. You can definitely do that. Yes. Okay, I think node port is good. So coming to the external IP. So this is where I was just mentioning, right? You can hold on. Let's clear this and then let's try external IP. I'll show you how the external IP address got added, right? So now let's look at the YAML file. So the YAML file says, see this, right? There is a configuration which says external IP. So this is basically an IP address which Katacoda has blocked dedicatedly for our application, and you can access this application using this IP address directly, right? So if I go here, I can directly use 80 and then I can access this application. I don't know if it is a dedicated external IP. It's not going though. Maybe it's the service is not an IP address. Yeah, okay. So I think this is an internal IP address only, 172. They don't have it blocked, but you can define your own public IP address here, right? And that's what this particular thing signifies. Now, if you go to kubectl get service, you can see where is that service? Okay, we did not even apply it. Okay, let's apply it. So I thought we applied. That's why this did not work. So let me apply it and then we can access this. Now, if I do a kubectl get service, we should see the external IP. See this, right? So this external IP now got populated with the IP address, whatever we had mentioned in the YAML file, the external IP, right? The host IP address, whatever we have defined within that external IP. If I show you again, so this is the place, right? The external IP has something called as this. So we have just added this instead of the port number or whatever, instead of the type node type. We are not using node type here, node port type here. Instead, we are using cluster IP, but we are using an external IP address with it. Okay, so this signifies that we can directly use our application and hit this particular port, and it will redirect to the cluster IP, and that's how it comes into the cluster. So I can directly use it here. So I can do a curl. I think this is an internal IP, that's why it's not exposing outside. But yeah, so that's how it was. It'll be done. Okay. So I'll just show you for your reference once again. So this is the external IP which we defined here. Any doubts here? Finally, we will see the load balancer. So the difference between an external IP and the load balancer is, in the load balancer, your type will be load balancer. Okay. Here we have the type as cluster IP, and you have an IP address pointing to an external so that we expose it directly, right? But in the load balancer, we will have the type of service as load balancer, right? And we will have a separate external IP which is pointed to or communicated with the load balancer within the cloud platform, right? That's how it is. So the target port to node port is how the access happens while you hit the external IP to node port. Correct. So that's how it exposes, right? In this case, target port and the node port, the port are same, right? The node port is not even shown up here. We don't know what port it uses to interact within the cluster, but yeah, it just shows that okay, it's mapped on port 80. But you're right, Shiva, it does that. Okay. So with that, we'll move to the final one, which is the load balancer. So this example is specific for load balancer. Let's look at the load balancer YAML. Now the difference between the others and this is the type will be dedicated as load balancer, right? So that's how we will be exposing this particular service. And notice that there is no port mapping because the port is exactly the same. If there is a different port, target port, you can define as a target port and then you can map it. But since the application is also running on 80, I want to expose the same on the load balancer. So I am just defining only type as load balancer, nothing different here. Okay, so that's how it does. Now, how does it show in the service? When I do a kubectl get service, you can see that where is it? Did I create it? Okay, I did not create it. I did not create the load balancer. Let's create the load balancer. So see that I have now a load balancer configured. The type of my service is called as load balancer, and it's exposed as the same IP address because that's the public IP address which is assigned to my login. Right, I can see that here, and if you see here, it's randomly redirecting to 30,827. Right, and this is the port which we didn't define, but that's the port which is free, and that's how it is automatically redirecting. Right, Shiva, you were asking. Yeah, this is how it does. Okay, that's all we have actually. So these are just the steps to access our application. We just did it already, right? Yeah, we can directly use this IP address to access our application. Any questions? So how does the request reach to the container? So that's a good question. So if you see this architecture, right? Now, how does the request reach the container? And this is how it does. So you use the cluster IP. There will be a core DNS which is running inside Kubernetes. The request comes in to that DNS. The DNS gets resolved saying, okay, this IP address is for this particular cluster. I will now redirect everything to the cluster, and from the cluster it moves to the specific service based on the IP address, the cluster IP mapping which Kubernetes has. Right, there is a cluster IP table which will be present within the cluster, which is where all the IP addresses which we have, right, which we saw here, all those will be mapped, saying for this particular application this is the cluster IP, for this particular application this is the cluster IP. All these are mapped within the cluster IP tables. Within that table you will have the mapping, and based on the IP address lookup it will go to that particular service. So it will first hit the service only. The service will then do the mapping, or it will identify which all labels are present for the pods, and it will redirect the traffic to that particular node. Right, again it will do the node, it will have its own node lookup, and then it will do that. Right, and that's how it does. Okay, any other question before we move on to the next one, which is ingress routing? Can you explain multi-cluster communication? So for multi-cluster communication, obviously you will use something called load balancer. Right, if you want to access or expose your IP address, you can also do public IP, and then you can expose it within your within the this public IP address could be your on-prem or LAN IP address which you are sharing across. Right, you can do that as well. Right, or you can use a load balancer which can be integrated to an on-prem or your cloud specific load balancer. Right, so which you can configure, and this load balancer will register to that load balancer and then get a unique IP address, and you can do cross communication cluster. So from one cluster you can use the same IP address and then communicate it. Right, try deploying the same Kubernetes deployment in a Google Cloud platform. You will get a public IP address, and that's what is a load balancer. Right, when I say load balancer, I will get a public IP address which I'll be able to access it. Right, you can use the same. That's how you will be doing multi-cluster communication. Right, most of the time what people do is they will do a DNS lookup, or they will do the external domain name mapping for that IP address, so that you can abstract the IP address with the domain names. Right, something like for example kubernetes.com or something, cluster1.kubernetes.com. Then for cluster 2 they will have a different name like cluster2.kubernetes.com, something like that. You can do that. Okay.
Hey Ajay, yeah, one question. So,
Yeah, Prachi.
yeah, when you said the request from external IP reach to the container, like from external IP, it send the request to the service port, which is the port actually specified in the YAML, and then it target to the container port as the same as a targeted port.
Correct. So it will first see, if you look at the, I think I closed it. Oh shit. Yeah, if you had looked at the service, right, whatever port is mentioned in that service, it will go via that. So what if let's say we used a node port and then cluster IP, the cluster IP will be hit. That IP address is what we will be giving, right, to the Kubernetes cluster. It will go to that IP address and then it will look up the service here, right, saying, okay, this particular service has only this particular port, and then it will go to the service. Then service will be running on that particular port only. Right, I mean, if you look at it, then it will be internally having its own mapping saying for 30,080 port I have a mapping for my pod saying it is running on 80. So that's how it does map. Yeah, yeah, whatever you said is right.
Okay, so though we have a node port, it still send the request to the service port and then container port.
No, the service itself will be exposed in the node port in terms of node port, but for others it will use its own port.
Okay, so port is used for the external IP or cluster IP use cases, you are saying.
Node port is the only use case where it will use the same port whatever you give, For others, it will be using its own port.
Got it, got it. So for external IP and load balancer, you're saying both are the public IPs, right? Like we create the, as you like you will be covering. So basically, suppose I want to give a type load balancer. So I should have an Ingress, and that Ingress will create a ALB in the AWS, and this is how it works, right?
Correct.
So so in the external, like what is the use case? When do we use external IP and when do we use load balancer? Like,
so when you don't see, load balancer is where when we want to plug and then create a seamless HA kind of a configuration, right? That's where you will use load balancer. But let's say you have a dedicated cluster, you are going to run only in this particular machine only, right? That's when you go for external IP. Okay, where that particular machine itself is exposed to the external world. For example, I bought a VM from Google Cloud, okay? And that has an external IP address. That is external IP. But I'm leveraging Google Cloud Platform's load balancer, right? To expose, to hide everything within my cloud account, right? That's when I will go for load balancer. You got it? Like this is like traditional deployment versus cloud-based deployment. So in a traditional deployment, what we do, we have a dedicated server, we have an IP address, and then we expose that as an external. The whole machine will be exposed as an external public IP address. That's where you will use the external IP.
Got it. So you're saying the load balancer, we have a multiple, it can send to multiple requests to EC2 instance or
Correct.
any.
You don't, yeah, it will be abstracting the whole cluster IP address itself, right? You will know only the load balancer IP address, which Google takes care. It will have its own 10 different DNS or whatever, right? That's how Google does it, right? Different mappings and all. And then internally, you don't have to expose anything to external world. Google knows what you have, right? Google has its own lookup. They will link with all the core DNS, and that's how they will look up which cluster to redirect to, and they will take care of doing it. But with the external IP, it's a dedicated machine you are hitting.
So the like companies in the production environment, they prefer load balancer type?
Correct. They prefer only load balancer. We will not use external IP at all.
Even
right?
node port.
Node port, specific use cases people try to use. For example, let's say you have a third-party application which you cannot run on a different port number.
Okay, they have a restriction. They can only these ports. And
correct. There are applications like that where you nowadays everybody is containerizing all applications, right? So there could be some legacy application or some vendor application which they say I want to run only on this port, right? I block other ports. In that case, you will be using node port.
Got it. Thanks a lot. And can you please cover in the last, if you can cover the the type, like it's a running, pod is running, crash loop, back off, and evicted state, those states. If you
that will be too much, but definitely the documentation is there, right? But these are like pod life cycle stages. I can show up. I mean, I can touch bit.
If you can show only evicted state, I always confuse with what is evicted state. Yeah.
Okay. Sure. Definitely.
Thank you.
Yeah. Rajesh, you had a question? Yeah.
Yeah. Hi, Ajay. I just want to understand the difference between the core DNS and what do you call that, kubeproxy?
Right. So kubeproxy is within your deployment, right? If you look at my diagram, right? So kubeproxy is deployed on each node, right? So any request which comes in, it will come via that proxy only. It doesn't do anything intelligent. It knows only with the context which is within your within this particular node. But core DNS is where you leverage it for domain lookups, right? Where what IP address, for example, these IP addresses are all made by Kubernetes, right? These are virtual IP addresses, right? The worker nodes or the pod IP. If you know, pods have like an IP address.
Yes.
Right? Those IP address lookups and all core DNS will manage. Right? And kubeproxy is just a proxy layer. Like for example, you send a request. That request comes via kubeproxy, then only it goes to the Docker container. Right? And the response also will go via the same. So this is just that's the difference between these two.
Okay. The internal like kubeproxies have 3 more modes, right? Like IP tables, some other modes are there.
Right. So those are like within correct.
So when each mode will be used actually in which purpose?
Right. So when you use a service mesh kind of a construct where you want to do in-depth analysis, or for example, you want to monitor your application, how many requests are coming in, what is my status code for each of my HTTP requests or something, that's when you will tweak the kubeproxy. And for example, if you are using Envoy, right, Envoy can integrate with this kubeproxy, and then you can do all those modes which you are saying, right? But in a general construct, we don't touch that.
Okay, fine. Thanks a lot.
Cool, man. Yeah, Manohar, you have a question?
Manohar?
Yeah, are you able to hear me?
Yeah, now we can hear you, Manohar. Yes, go ahead.
Yeah, in the deployment.yaml and service.yaml, there is a label selector name is there, right? actually there I'm able to see in multiple places. Under the template is one thing, and under the top spec one more thing is there. So I'm getting confused which particular property is using that particular thing in the both the sections. If you open
Yeah, I get it what you're saying. Oh, no, not here. I think we might have some scenario here also, right? This one, right? We have something
yes,
called
yes,
labels, and then we have selectors here also,
yes, yes,
right? See, the thing is, the
yes.
difference between these two is if something is there in a metadata, right, that is specific to this particular service or whatever you're creating. For example, this is my service name. I'm providing a label for it.
Okay.
Okay, that is only for this. I can give this label to have a different name also. But then there is something called selectors. Selectors are basically what pod should I select for this service. Now, if I go to the deployment here, you might see there is something called spec here, right? Within the spec, you will have labels, right? This is what the selectors will map to. But you can also have in the metadata also you can have something called labels. That is just only for querying purpose. In kubectl, the whole kubectl command, right, using which you can query deployments or you can query services using labels. If you do a kubectl get and then you can say -l and then it will query only that particular label. So basically it's like tagging in AWS. If you have worked with AWS, you have something called tags, right? In AWS, it's exactly like that. So that is what the metadata labels are. The selector labels are specific to specification, which will be inside your specification. That is what this guy will refer to. For example, this deployment label will be used or selected within the service 3, which is this service 3 is this. See this here. Since the name is same, you get confused, right? I mean, most of the time the names will be whatever we give here will be the same. Here also will give the same name. Here also will give the same name. But the difference between these two are this is for querying your service and this is for your selecting whatever deployment. And here also you will do the same for tagging your deployments as a common label.
So it is like in the deployment some definition is there, means like how in the servlet mapping we will do, and in the service that is like mapping is there.
Mapping in the sense, yeah, the
It's like,
service, correct, exactly, correct. The service is what will select your pods, will your deployments, correct, right? So in the deployment, you will define, please call me by this label. And in the service, you will say, please select this particular label. What all pods are there with this label, it will select all those.
okay, we have to under whatever the bottom of the spec.
Yes, it is only under spec.
Just
correct. It's just for only for us to query the resources.
Okay, in the deployment thing there under the template metadata
correct.
labels app is there. So that is the definition.
Correct.
And the service that selector app is the corresponding mapping.
Correct. Yeah. This label is specific to service only. It's not specific to this guy. So that's why, I mean, when you copy paste and replace, right, you will get all these kind of issues. I've seen, like when I started working with Kubernetes 2 years ago, I used to have the same issue. Which all should I replace, right? I mean, when I create a new app and I rename. So yeah, this is how it works. So this is metadata specific to the service. This is specific to the deployment. Okay, cool.
Yeah, and one more question is there. So the thing is like when we are working there, we are getting the Kubernetes token, KTS token, and we are putting under the UI, we are able to log in. And same thing we are doing from the Jenkins pipeline, right? So when I'm looking from Google Cloud Kubernetes thing, there that is completely from UI I'm able to manage, but how to connect it from my local, still I have so lot of doubts.
Right, so that's where the current context will be helpful, right? You have to use different authenticators for different platforms. For Google Cloud, you have to use Google Cloud CLI, right? For AWS, you have to use AWS CLI with IAM authenticator, right? Then what happens? Your kubectl will integrate with the Google Cloud CLI and then get its token, right? There will be kube.json file, right, which will be created. The kubectl CLI JSON file, which will be created. It will use its credential, and when you do a kubectl current context, it will show whether it got connected or not. All right, that's how you will know. So you have to identify how to integrate. Which platform do you use? Google Cloud.
Yes.
Yeah, then you have to use the Google Cloud login.
That CLI needs to be installed in the local machine, client machine, and from there it needs to connect via command.
Correct. So I have done it like with Google Cloud, right? Some time ago. I think I have the command. but
Actually, I followed your tutorial, then only I followed that thing.
okay,
Directly
okay. So this
followed
is
it.
there will be a command for doing that, right? I mean, in the GitHub it is there, right? I mean, you can definitely do that, the Google Cloud command. But yeah, I mean, connect with me offline. We can see.
Yeah, yeah, sure.
Okay, cool,
Thanks.
man. Any other question?
Ajay, so in the interest of time, can we take the other questions at the end?
Sure, sure, definitely. Yeah, yep,
Sure.
yep, yep.
Thank you.
Yes. So the next topic is ingress routing, right? I mean, this is an interesting topic because let's take the same example, right? We have the front end application, we have the Redis backend, we have the worker nodes also. The blue ones are the pods. The service is what we were exposing, right? Now I have two different versions of the product. Let's say this particular version is called V1, and I want to access it using v1frontend.com, and I also deploy a new application, right? Which is a new version of the application, which is v2frontend.com. Now how do I access it, right? Now how do I create it? So that is where we will be creating something called ingress. So ingress is similar to service, right? Like how you created a new what do you call container kind of thing which is running, which was created by Kubernetes. We have to create something called ingress for it, right? Using ingress we can define which endpoint goes to where. So it acts like a routing layer to route your request from your host name or whatever. For example, I can define if the request is coming from v1frontend.com, then redirect it to frontend v1 application. If the request is coming from v1 v2 frontend.com, then redirect to a different application. I can do that kind of logic, right? That's where ingress will be helpful, right? Again, I mean, this is just a fancy meme, right? I mean, if you look at it, we did not write any code till now, right? We were just creating YAML files. So the question we all think is like, are you all YAML engineers now? Like, are we just doing YAML coding, right? But funnily, yes, that's the current state. Every tool is now coming up with YAML, and then you can create only YAML, right? So with that, let's go to the hands-on, right? For the ingress, if you see, it's a four-step process. First, I'm creating something called deployment. Let's look at what all got created. There are three applications which got created, all right? So there are three different pods, three different services which got exposed, right? And that's what the first step is. Second step is to deploy the ingress. So this is where we will be looking at ingress. So what is ingress? Ingress is another resource, like I said, right? I mean, let's look at what is ingress now here. Where is ingress? Okay, let's create the ingress and then I'll show you what it means. Okay, this is just the deployment, which is Nginx. So we are deploying a manual ingress, which is Nginx right here. Nginx is like a load balancer. You can use it for load balancing your application, and also you can use it for reverse proxying any request within your application. So this application is coming up. Let's go to kubectl get pod. So the application is up. The ingress also is created. Let's go to the next step. Yeah. So if you remember the logic which I was mentioning, which I just mentioned here. So we want to have some logic based routing to our application, right? And that's what can be done with ingress, right? So if you look at this particular logic here on the left side, if somebody accesses the application using my.kubernetes example, then, and if they access web app 1, then redirect it to a particular service. So what they do is, based on the path, they redirect it to a different service, right? And that's what you can do with ingress, and that's the logic here. So let's open this YAML. So this is the kind similar to how we created service and deployment. There is something called ingress. So you can do kubectl get ingress to look at the rule here, and this is the ingress rule. So it says if my application is accessible from my.kubernetes.example, and if somebody accesses my.kubernetes.example / web app 1, redirect them to a service which is specific to that. If they access web app 2, point it to a different service, right? And that's how they do it. Right, let's look at now kubectl get ingress. So you can do kubectl get ingress, and this shows up the configuration which we just created, right? You can also do kubectl get service to look at all the different services which we have. Service 1, service 2, service 3. These are the different services which we saw. Okay. Any doubts here? Pods. See, these are the 3 different pods which we had. Now, how do you access them? Like I mentioned, you have to provide the host name, right? I'm doing a curl with a host name with a specific app. For example, here, I think the application is it up. It says connection refused. I don't know why. I think the ingress is still not created from what I see. It still takes a while, I guess. Yeah, the ingress points to the separate resource which will be within the Kubernetes deployment. I think it's still not up, right? And that's why it is taking a while. But yeah, but this is how you can do finish. But this is how you can do ingress, right? I mean, it's nothing complicated. It's just another resource, like how you have service and pod. It's just another resource where you can create new rules, and based on that rules you can do route traffic to different instances. Mostly people use it for A/B testing or blue-green deployments and things like that, and that's where we use ingress routing, right? Any doubts? I think it was straightforward, right? I mean, what is the difference between ingress and load balancer? So ingress we will be able to do the same thing as the load balancer, but which is controlled within the cluster, right, Suresha, right? In general, what we do in the load balancer is the same thing. We redirect traffic to different we redirect traffic based on the what do you call, number of resources which are available in the instances. Ingress here will do, in addition to that, it can also do path based routing, but generally load balancer also is doing the same thing. But this ingress, whatever we saw, is within the cluster, right? I mean, which is specific to the cluster, and you can do the same thing within Kubernetes also. Generally we use load balancer which is outside the cluster. The same feature is available within the cluster, right? The difference between ingress and traffic is the same. So traffic is just another type of ingress load balancer, right? Like Nginx, it's the same software. Okay, so that leads us to another important topic, right, which is readiness and liveness. So readiness is useful. Anybody knows what is readiness? In general, I would have asked this question if it was in person, but generally readiness is used to verify if the application is ready to accept traffic, right? This is not like the health check, but this is like a signal to say I'm ready to accept traffic, right? Generally what happens when we deploy an application, the application takes few seconds to come up, right? This could be in terms of seconds, till some application takes minutes, right? So readiness should be available only when the application is ready to accept traffic, right? In the sense, if my application takes 5 minutes to come up, my readiness health check should check only for 5 minutes, like it should wait for 5 minutes until it comes up, right? That's what is readiness, right? And liveness is used to verify if the application is up. This is like heartbeats, right? You check the heartbeat. If the application is not sending any heartbeat, we can try and restart the application, right? I mean, that's the same thing. Like, I mean, I mean, it's different from readiness, because readiness says my application needs 5 minutes to come up, then only I can serve traffic, then only I will be ready. But liveness says something happened to the application, now I need to restart, or I need to undergo and restart, right? And that's what liveness is. If you relate this to a real world example, right, readiness is similar to how a newborn baby is born, right? I mean, when it comes into life, it's like ready, right? And heartbeat is similar to liveness, right? Where how do you know you're alive, right? I mean, it's based on the heartbeat, right? And that's what readiness aliveness is. Obviously we cannot restart our lives, but we can restart a container, right? That's where it is pretty helpful. So readiness is when can your application accept traffic, and liveness is what happens, like is my application alive or not? Should I restart the application to see if it is really having any issue or anything, right? And that's what is readiness and liveness. So a lot of people were asking readiness, I mean, questions on readiness and liveness. I hope this has solved your puzzle, right? Now, how do I define that within Kubernetes? Obviously, you will have to write a YAML configuration. There is something called readiness probe. So this particular section, which you see here, within the containers in your deployment, you can define this section. Saying, for example, this is a HTTP example. For HTTP, I'm saying if my path readiness doesn't return 200, right? And this is the port which I'm using. Wait for like 300 seconds, which is 5 minutes, right? Wait for 5 minutes because my application is ready. I mean, usually ready only after 5 minutes. And also every 30 minutes check if the application is still ready, right? So even after the application is ready, every 30 minutes, your readiness health points will be checked, because if something goes wrong with the readiness, then again, the application is down. We need to recreate the application, right? So every 5 minutes, it just check. I mean, the initial delay will be 5 minutes, and every 30 seconds, it checks if the application is still up, right? After the 5-minute period. And that's what is readiness. And this is how you can configure. If let's say you have a batch application, or let's say you don't have an HTTP application, you are not exposing any endpoints, then how do you do it? There's a option for you to do it using exec commands. You can check if a file got created or a log got created or something like that using exec commands also. That is this example, right? All these are available in the documentation, right? Let's look this with an example, right? With the scenario. Any questions meanwhile while we are going to do it? Whatever I just showed, I'm just going to do. I mean, nothing different. It's very straightforward. It's not complicated. I'll just show you the examples, right? So here I'm going to launch the cluster. No, kubelet will not store these readiness and liveness. These configurations are stored in etcd, right? And based on that, controller manager will know, right? And kubelet will send, controller manager will be like, I mean, obviously kubelet will send information about it. Kubelet is what will be sending the information, but yeah, it'll be getting it via etcd. So controller manager will ask kubelet saying, okay, is it ready still, right? So controller manager is the guy who will ask it. So see here, let's open the deploy.yaml. So this particular deploy.yaml has a front-end application, and see that there is a readiness probe defined here. So the readiness says the application should be accessible at / initial delay is 1 second, timeout is 1 second. So every 1 second, I will be checking the readiness, and also the application will start up in 1 second. And also liveness, I've given it as 1 second. So liveness is like if the application is live. Here I'm just giving the same path, but generally don't give the same path in production, because liveness just denotes whether your application is live. Readiness denotes when your application is ready to serve traffic. Sometimes you want to have your cache populated, right? That's when you will be using readiness extensively, right? So so there are two applications here. One is the bad front end, and there is one front end, right? And we can see how the application is behaving. So let's do kubectl get pod. See that the bad front end is not ready yet, and it is restarting. See this, right? Why restarting? That means the application is the liveness failed. When liveness fails, it restarts. But when the readiness fails, it will recreate the application. Okay, so the difference is when readiness fails, it will recreate the application. When liveness fails, it will restart the application. So the restart will keep on happening actually for some time, right? Based on the timeout. Okay. That's what is explained here. So here it's, see, this is just the selector which we gave. We want to select only the front end. This is again the same query, nothing big. Oh. Why did it complete again? Shit. It started from the beginning, but I think it was very quick. Let me start it again. Any questions on it? But this is what happens, right? With readiness, when readiness fails, your application will get recreated. With liveness, your application just gets restarted. We just reboot sometimes, right? I mean, it's similar to how our laptop gets crashed sometimes. And when we reboot the laptop, we are okay with it. But sometimes our blue screen of death comes, and then our laptop goes for a toss, right? So it's exactly similar to that. Readiness is like that, and liveness is when your application is ready for serving traffic. Right. Correct. When you see restarts, that means liveness. Correct. That's exactly right. When you see restarts within your application, most probably it's because liveness failed, and then Kubernetes is already restarting it to try if it works, right? But if let's say the pod keeps on recreating, that means the application is never ready, or the application did not come up at least online, right? Once. So that's what happens. So that's the whole idea. So I do see restart on the pod. Yeah, so that's where the whole liveness would have failed, right? See, first time when the application came up, readiness would have come in. If readiness also will have a timeout. If you remember, there was a timeout which we had, right? I mean, the which I showed in this thing, right? Initial delay. I think there is a timeout period, right? I mean, you can define a timeout period and then say after this particular timeout period, the readiness can recreate the whole thing. So you can define and control that, Prachi. Okay. So already I think half of you are like, when will when will this meeting end, right? There are too many things to do. Finally, we are in the last topic, right? Obviously, it is not ended yet, but this is the last topic, which is secrets, right? I'll not take much time, but I hope I'll end before 5:30. But this is the thing. So secrets are usually used for storing sensitive information like authentication tokens, passwords, SSH keys, and certificates, right? Obviously, like we were discussing in the initial session, if the passwords are stored inside secrets, it won't be secure if the cluster got compromised, because the cluster will have the password stored within itself, right? So generally don't store the passwords, but secrets can encrypt it with hash, with just a hash 64 encryption, but base 64 encryption, which is not secure though, right? But yeah, that's the whole thing. But secrets are useful for storing sensitive information, right? And all these are stored inside HCD, right? That's the data store for Kubernetes. So we saw a database within Kubernetes, which is HCD. That's where the secrets are stored, right? And this is how it looks like, right? Within a container, you can have an environment variable. You can load the value from a secret. For example, simple secret is a secret which I'm going to create. So in the hands-on also, we will try to create a secret, and within the secret we have a username. We are trying to load that and store it into a variable which is secret underscore username, which will be used within this secret example, right? This is just a sample for secret. The other way of using secret, instead of loading it into an environment variable, we can mount the values into a file system, right? This is another way of doing it, right? For example, if you have JKS certificates, right, you can mount that certificate, you can put it into Kubernetes secrets, right, and then mount that certificate into the volume and use it within the application. So this is one of the common use cases where we use secrets, right? So that's one thing. Okay, so with that, we'll go for the labs. Where is the secrets? Kubernetes and manage secrets. Okay, let me launch the controller. See, this is how you can create a secret. So secrets are another kind. So whatever we saw today, right, from the morning, we saw service, we saw deployment, we saw ingress. Similar to them, secret is also a separate resource, right? So when something is defined as kind and then something, that's a separate resource, right? Secret is also a resource. So see here, this is another resource, right? And within that resource, we are creating a username and we are passing the username, password, we are passing the password. All these are stored in secret. So let's create it. So see here, what I'm doing is I'm having a username as admin and I'm passing the password as some encrypted value, and I'm just encrypting it into base 64 just for edit, right? So so we have created two variables, username and password. Now I'm going to create a new secret. So how do I create secret? You can just say kubectl create -f. Again, you can provide the YAML which we created, and once it is created, you can just do a kubectl get secret, right? You can see all the secrets. So we just created something called test-secret. You can do a kubectl describe to describe that particular secret. Oops. Right, and you can see that the passwords don't show up. The password or the username doesn't show up. It just shows the 15-byte thing. In config maps, you generally can see the value, but in secrets, you cannot see the value. That's the major difference between secrets and config maps, right? And in config map, right now we created a type called opaque, right? If you see this type called opaque, you can also create a type called file, right, where you can store your passwords or your JKS file, and then that can be loaded into secret and you can use them, right? So that's how you can use secrets. So we have created the secrets. I think we just saw it, right? So we created the secret. The now next step is to use it in the application, right? How do we use it in the application? So like I mentioned earlier, there are two ways. One way is to load it as an environment variable. So how can you do it? This is the code. This is the configuration for it. Use the test secret, get the username, load it into the variable called secret underscore username. Right, so we are saying value from secret reference, get it from test secret, the username. Same way for password also we are getting it. Okay, so that's how we are retrieving it. Let's create this container and we can see the value inside, right? This command is for logging into the container and then viewing the value, and you can see that the admin and the password got injected into the container and we can see them. Okay, so this is how you can load the secrets into the container. So the next step is to consume via volumes. Like I mentioned earlier, if you look at the volume, see that I'm going to create a pod with a volume here, volume mentioned, which is etc secret hyphen volume, and I'm going to create a new pod with that. It is the same secret, the secret username and password, but I'm going to mount it like a volume within the pod. So I just did that using this command, right? I'm creating some volumes like this. This will automatically mount my test secret into a volume and into this path. Okay, that's how it does. So both the username and password will be mounted under this particular path, and we can look at look like this here. See that the username will be the file name and the value will be within that. So I can see what is my username, admin, password will be this number. Okay, so this is how you can use secrets as a mounted way and also as an environment variable. Okay, with that, so what next, right? So if you had learned all these, I would want you to I mean, I obviously you guys want me to end the Zoom meeting, but there is something called Game of Pods. If you guys are interested, try that out. Right, you can go to codecloud.com/p/game of pods. Right, you can definitely leverage that. I also had some sample challenges and I solved them with the answers which are there here. If you guys are interested, you can take it from there. Obviously, the slide deck is available in this link, Cube 101. Right, that's all I had. And if you still think like it, whatever I made sense, you can follow me on any of the channels here. Right, with that, that's all I had. I mean, if you guys have questions, I think I see Greether had question.
Yeah, hi Ajay. This is non-technical
Sure,
career at
definitely.
first. So right now I'm seeing this Kubernetes and containers and all in my company for last 1 year. But I'm basically a sysadmin into security. I do SOC and also. So how does that work out? Like, let's say I'm already working on this, and today what and all I learned is totally new from what I already knew. So how does one should go about searching for a job?
For your role, right? See, whatever I showed you, these are like the developer specific stuff, right? I mean, it will be helpful for you to deploy applications. See, what we did here is we deployed application, we leverage different resources. It is good to know, right? I mean, if you're a sysadmin and then you want to do security related stuff, if you don't know these, right, you won't know how to log into a specific pod or something, right? I mean, you should know all these, but you don't have to go in depth, right? I mean, we would have discussed a lot of in-depth stuff, right? You don't have to know all those in-depth stuff, but I would say do whatever. I mean, if you had known what is service, what is deployment, what is pod, if you know how to log into the cluster, what is secret, then it will be very helpful. See, talking about security, you should know the system end to end, right? Then it will be very easy for you to understand where things can go wrong, right? So I would say definitely learn all these and then learn the basics. You don't have to go in depth, right, and how to do complicated stuff and all, but that's how you can go about it, right? Now, that's the easy part. On anything, not just Kubernetes, right? I mean, specifically if you want to look at security specific things, know the things from the basic and then go and identify which all things can be exposed or which all things can be weaker. For example, the secrets, right? That's a weaker part. If somebody is creating a secret within your company, you can go and say this is not encrypted properly, right? You can go and try and decoding the password yourself with base 64, right? I mean, that's a vulnerability, right? That like that, you without knowing the system, you cannot do some stuff, right? So I would say know the system, then go in depth into your security specific resources. That should help you. Okay. Next, Rajesh.
Yeah.
Rajesh.
Sorry, Ajay, I could not unmute myself.
Sure,
So
no, yeah, good.
even security, to me, what I see is that basic, without knowing basic, there's no security.
Correct.
I was more inclined to this Kubernetes and even before that container, Dockers and all. So I would like to go in this direction. to be able
So
to
you
be.
are in the right direction, right? And next thing what you should look at is the best practices for running a container, right? For example, you should not run Docker containers within Kubernetes as root, right? That exposes a lot of vulnerabilities, right? That's a security vulnerability if you ask me. So like that, you should identify what all things, right? And now you can go in depth on what all things people can have access to, right? Since they can run containers within whatever, within an isolated environment, right? What all accesses each of the pods have within the resources. Can it create 1,000 pods? Can one pod create another pod? Does it have a boundary? Can I communicate with application which is outside a namespace? Those are the things which you can look at. So obviously, if you have your basic strong, whatever we just saw today, it's going to help you a bit.
No, Ajay, my question is like how, where should, like even in LinkedIn, when I search for, let's say, container specialist, what are the keywords that I should search for when I'm trying to get a job? And obviously, this is going to be a 180-degree shift where my long term is to learn in this direction, because for the last 1 year, I'm learning this and I feel it is right fit for me.
Sure.
So, how
One
do
thing is what I would say is create a portfolio which you can showcase to your recruiters, right? I mean that's the thing. And also you can look at, see, if you look at it, security, when you mention security, it comes into any cloud platform, right? Not just Kubernetes, right? I mean, if Kubernetes will be like one restricted thing, but I would say explore all the cloud platforms, right, parallelly. And then for your learning path, how do you identify and all? You can create your own portfolio and then start creating some project, build some small thing, and then expose something, and then try to solve it with an example. Try handcrafting yourself, which you can show, right? That is one example of showing, right? Identifying people, I mean, obviously you have to look through the job description. That's the only way. That's what I can see. But yeah. Cool. Yes, Rajesh, go ahead.
Yeah, thanks.
Thank you, Girish.
It's a very good session.
Thank you.
So another thing is I just want to understand the troubleshooting part in real time in real time scenarios. Do you have any YouTube videos with respect to this?
No, I don't have anything dedicated. But yeah, it's a good question. A lot of people have been asking me how to do troubleshooting. Maybe I'll think of it. Maybe, I mean, we can check with Prakash, and we want to have a session on troubleshooting in Kubernetes.
Yeah,
right? I mean,
right time, I guess I need to ask this question, but
correct,
to ask one question because
correct.
I'm not having an answer for this one. Can you please ask me what is the answer for this? So the thing is that I'm rolling out a new version to my Kubernetes cluster. If I want to roll back to a particular pod only, how do I need to go ahead actually?
Got it. Got it. So there was one session on best practices, right, which I had seen, which was helpful, right? But try googling out, right, in some of the Kubernetes conferences, right? I mean, I've noticed there are some sessions around best practices, right, or some tips and tricks on how you can leverage kubectl CLI, or tips and tricks in general on in navigating through Kubernetes. Those all were helpful for me as well, right, when I was working in production. So try those. That should be helpful.
Okay.
Right, that's what I think. Yeah.
Okay.
Cool. Thank you.
Yeah,
Yeah, TJ.
Yeah, Ajay. I have a query regarding the Kubernetes security. Do we have any automated tools to secure all the Kubernetes at a time?
You don't have like a tool to do so, because there are so many things inside Kubernetes, right? You need to do a lot of audit stuff. You need to there's something called service accounts, right? You can create something called service account, like how we created Ingress service or deployment. You can create service accounts which can create boundaries for your application access, right? Which can restrict you from doing some things, right? So there is no dedicated tool as such, but a lot of platforms are providing different tools, like distributions, like a lot of distributions like OpenShift or Rancher. They all have a customized Kubernetes, right, which will have all those embedded in it. Like you can plug in your on-prem authentication system into it, something like that, right? But there are no dedicated tools as such. There are some tools for what do you call fault detection. It can identify if the containers are having issues and things like that. I don't remember anything off on the top of my mind, but I saw one tool called Cube Audit, right? I mean, that was one for identifying and auditing logs and what do you call configuration specific changes within your cluster. If somebody is doing something wrong, you can audit within the cluster using Cube Audit, right? That was one. Right.
And one more thing, can we know the environment, how if you working in a production environment in your company, so how can we understand how many Kubernetes are there, how many clusters? And I think Savita has shown me the GUI, but can you show it again?
There is no dedicated, again, like clusters are individual, right? I mean, there is no, like AWS, there is no dedicated console which can show all the clusters, right? Even if you deploy your dashboard, which will be specific to cluster, right? I don't think there is a central dashboard for it. You can definitely use the cube dashboard for it, the cube dashboard which Savita showed, that will be specific to cluster, but I don't know if it provides cluster linkage. All right, if you can do that, you cannot auto explore. That's what I meant.
Okay, yeah, thank you.
Yeah. It will soon come, right? I mean, I'm pretty sure somebody is working on it, right? But in the cloud platforms, you already have, like Google Cloud has its own central console where you can do the same things. You don't even have to have a dashboard specifically for Kubernetes clusters, right? So, yeah.
Okay, thanks.
Yeah. Hey Ajay. Yeah, the one I asked actually, evicted state. Can you like, what should we do when we get evicted state? Because I saw when a pod is in evicted state, it's tried to create a new pod, right? And we need to remove the evicted state pods. Like it,
Right.
like else we have a
Yeah.
script.
The evicted state is something like crashing, right? I mean, if something crashes, we cannot do anything with it, right? The only thing we can do is, based on the logs and the metrics, we can identify why it got evicted or why it got removed out of the cluster, right? It could be because of memory issue, it could be because the node crashed, or it could be because of something which happened within that particular pod or something, right? So that's what I can think of, and we have to debug, right? There is no direct reason as such why something will get evicted, but when it says evicted, that means something bad happened, so Kubernetes immediately removed that pod outside the deployment and it created a new one.
Okay, okay. It doesn't mean a pod is evicted state, it's because of disk pressure or a memory. Like it's
Yeah, it can be multiple reasons. It could be memory, it could be out of memory. It's like how your laptop suddenly restarts, right? Or your phone suddenly restart. Why does it restart, right? It could be because of so many reasons. So it's the same thing. It's exactly the same. It could be because of some internal code exception also, right? It can happen that way as well.
I see. Cool. Thank you.
Yeah, cool. Yeah, Manohar.
Ajay, for a microservice developer, is it required to having this much in-depth knowledge in Kubernetes? Because we are not the admins, we are not managing the environment. Just deployment is the enough for us. So.
See, but without knowing secret, without knowing how Kubernetes does service discovery, it's very difficult for us as developers, right? See, I am a developer only, right? But I still know everything, right? But without knowing these, it's very difficult for you to visualize and then think, right? Like you said, as developers, you just sit and code. But when you become an architect, the developer is not going to be a developer for long, right? What I feel is, obviously at one point you will become an architect. When you become an architect, you need to look at all these, right, on how things work, and that's when you can say, oh, okay, already Kubernetes has some service discovery kind of pattern, I can leverage it instead of deploying it separately, right? So I would say, as a developer, irrespective of whether you are a developer or a operations guy, you should know at least the basics, right, on what all things. You don't have to go in depth, right? Know at least, okay, these are the features which are there in the platform, and see if it fits for you, right? So I would say, like, know the basics, right? Don't go in depth.
Okay.
Does that make sense?
Yeah, sure.
Cool. Okay, hope that was okay. So also do give us some feedback on the whole structure of the meetup, right? I mean, if you guys have any feedback on what can be improved, you can share that as well. I mean, that will be very helpful for us to grow as a community as well. And even for me, if you think like I should have changed something or slowed down somewhere, or I feel it was okay, but somewhere we fastened, but I think it was okay. I hope you guys were able to understand, right? If there is anything you can share it with us.
Yeah, so we've come to the end. Ajay, if you're okay, can we just throw it open to bring in Nabarun as well and everything?
Sure.
And throw it open as an open house, as you can ask any questions related to Kubernetes. It doesn't have to be related to the sessions that happened as well. So.
Sure.
Guys, if you have any questions, you can raise your hand. You can raise your hand and ask the questions. Yeah, And if you have feedback as well for us, you can just raise your hand. We'll unmute you. You can give us your feedback as well. Right. So the feedback helps us in the way that it also helps us making the experience better the next time, and it benefits the entire community as a whole. So we appreciate the feedback.
Yeah, so feedback link is on the Meetup channel, right?
Yeah, we can put a feedback link as well.
We want to open feedback. I don't think we have a form as such, but you can just mention, Prachi. I mean, it's okay, right? We're open for anything. It
was really amazing and a wonderful experience. This was my first meetup I attended, and I would say in these 3 hours we have spent, I learned a lot. And if I'll go ahead and do all these, and this will be a good learning for my career. So one question, Ajay, what should I go for? CK, I don't have any certification and I want to do. What should I go for? CKA or
so
CK?
what is your role, right? I mean, for example, I did CKAD because I'm not a platform engineer, right? But Prakash, let's say, is a platform engineer, so he will prefer CKA or CKAD. So I wanted to understand everything, right? I mean, on how you can use Kubernetes, right? So that's why I did CKAD, so which is a Kubernetes certified application developer. So whatever I showed you today will be relevant for CKAD, right? But what are the internals of Kubernetes, right? I mean, that is where your CKA will be helpful, right? How do you set up cluster? How do you set up nodes and things like that, right? I mean, which is where CKA will help you, right? The administrator will help you, right? So you can choose based on your
Only, I belong to platform engineering only, but sometime we do troubleshooting as well, sometime we do create development as well, so it's
so
involved
you
both.
do CKAD first, because CKAD is a 2-hour exam, CKA is a 3-hour exam.
Okay.
Right, and it's like intense. Obviously CKAD, both are like that. Time is your only key, right? I mean, if you prepare properly, I mean, obviously prepare properly in the sense, I mean, if what happens is you cannot recover the cluster if, let's say, you did something wrong within the cluster. Right, because all these are configuration, you did something wrong and the cluster got screwed, right? Oh, now it's 2 hours, I don't know, now CK is 2 hours, I didn't know. But yeah, so it is of 2. Okay, they reduced it to 2 hours. Cool. Okay, so it's all 2 hours then. But the only thing is, time is the only thing, right? I mean, I attended, I think, 17 questions only out of 19 questions, right? Because I didn't have time. What happened is I got lost with one question. That question was very complicated, and I took 20 minutes and I lost 20 minutes in that question. It was a 12 pointer. Each question has different points, right? So it was a 12 pointer, and I realized that I should have skipped that question. But yeah, still I passed. But that's the thing. But it was a good learning experience for me in attending that question also.
And I think number of questions also reduced in
Is it?
CK.
Oh,
Yeah.
okay.
Okay, so
So
yeah, someone is saying something.
Good.
Yeah, I was saying, where should I go? I am not sure, how should I go ahead? Should I take some training or some blogs, or how should I start? There should
There
be
are some sample questions, but I would say go through each of these topics, right? There are some topics at the high level, like core concepts. They will say these are the things which you have to cover, right? For each of them, there are specific topics which you can cover. Right, for each category of questions, there will be like 10% of questions from something and things like that, right? You can cover each of these and go through the kubernetes.io, because during the exam you can open the documentation, read, copy paste and things like that. You don't have to memorize commands and all.
Okay,
Even
so
there are a lot of tips and tricks also. I mean, YouTube itself, I saw a lot of videos around tips and tricks on how to be productive with the command line interface, right? Because you don't have to remember all the things. You can directly go. If you see number one is pinging a link, right? You can directly go there as well, like the tasks. That though you can follow them, because most of the questions come from there only.
Cool.
And while doing practice, we need to make sure that we need to know for which concept how much percentage is allocated. So based on that concept, if we start practicing, it will be more useful if we consider exam perspective, and also it will give more idea on the entire concept also.
So you need to say to focus more on whichever is having the more weightage, you can start with those concepts.
Yeah, there is a handbook, I think, right, Savita? The handbook, you can follow that handbook. So in that it mentions what percentage of the questions will be from which, right? I mean, I can ping the link.
So my focus is more on learning. Like certification is one thing that I want to do. That I can, as you said, tips and tricks I can crack anyhow, right? The motive is learning, right? So in
Then you
those,
should be the next speaker in the next meetup session, right?
Oh,
Right, Prakash? That's how we
yeah.
learn, right? I mean, if you look at it, I'm just kidding, but yeah. See, one thing is try having a path, like learning path, right? What should I learn? First, I understood core concepts. Next, I will do networking. Then next, I will do security. Next, I will do logging and monitoring. Next, I will do storage. Like that, you can create your own path, right? Based on that path, then you can concentrate. Yeah, right. For example, I'll paste the percentage of whatever the.
And also if we follow the concepts, right, actually they covered in proper way, like how we need to proceed one by one. And other thing, like if you are a platform engineer, then better like start trying out deploying the Kubernetes without using any of the automation tool like KubeADM or something. I mean, don't go to AWS, which they already have automated. Instead of that, try to deploy your master and node component individually and make sure that how they are connected each other and how the communication works and how this etcd connection will happen. So this way you will understand what are the different modules or components as part of the master and node, and how what are the problems you will face when something is not up. So this way we will understand how, in depth, like how the communication works flow, and along with we will get to know like these concepts, basic concepts also.
Yeah, also to say that to second what Savita just said, a lot of your learning, at least this is true for me, a lot of my learning came hands-on. So I was studying, I was trying out scenarios and everything, but as long as you don't do, if you don't do it hands-on, you will forget a lot of things easily. The community is moving fast. There are a lot of things coming in, going out at the same time. A lot of things have come in and gotten deprecated as well. So it's very important to keep trying things hands-on, and that makes it easier to remember things as well, right? But the basic concepts remain the same, right? Nabaran?
Environment would be enough to do the practice and hands-on, or do you suggest doing it in cloud like AWS or GCP?
So
I
first,
would suggest doing on.
yeah,
So
go ahead.
go ahead if you want to.
No, go ahead. I'll take it later.
Okay, so the best thing you can do is on your laptop using Minikube or Kind. But if your laptop has less resources, use the Katacoda Playground. That's one of the easiest ways to do. It would be sufficient for doing any exercises for CKAD. For CKA, ideally you should have like 2 VMs, so that can be on any cloud provider. And that is only required for the cluster setup part. That's only 15% of the weightage, but 15% is a great deal.
Okay, got it.
Yeah, so if we are a basic user, then I would suggest, as they said, like we can start with the Minikube, and then once we are comfortable, okay, we can do it, then we can start exploring how the components interaction and master node architecture we can go at that level. That will be helpful for CK.
Yeah, thank you, sir.
Yeah, Ajay, I have a query. Actually, I'm beginner to the Kubernetes and I work as an information security analyst. Here, my question is, if we are installing Kubernetes on AWS, how the path is? First, taking AWS account, installing EC2, and how it goes. Can you tell me on that?
Yeah, AWS has made it very easy now, right? I mean, if you
Okay.
have an account, but it's different in a different setting, right? If you are in a company, right, you will not do the same kind of a fashion, right? You will have your own VPC, or you will have your own governance or compliance within your company, right? You will have to follow them, and then you'll have to see what is the strategy. Do you give users permission to create a new cluster, or how do you control them? Do you create a CloudFormation template, or you have the CLI itself, give them the whole CLI and then say, okay, create the cluster in one go or something like that. So it's different, right? But if you want to create EKS, there is EKS CTL, right? Like kubectl, there is something called EKS CTL, right, in AWS, which you can leverage and then just create a cluster in just a matter of seconds, right? I mean minutes actually. You can just trigger the command and then the cluster will automatically get created. You can mention what all EC2 instance types you want to create, right? Do you want to have small machine, medium machine, large machine? You can define them all. How many cores you want? You can define all those in the command itself. You can do that.
It means Kubernetes will be inside the EC2, or it will be inside the EC2?
They will. So Amazon would have installed in their own EC2. Master will be within their control. You cannot look at any master. They won't show you master and all, but they will show the worker nodes.
Okay.
You'll be charged only for you will be charged for worker nodes. Master node they will not show, but they will charge on a hourly basis.
Okay. If we have a couple of EC2 instances and different Kubernetes, can it be connected to each other?
Obviously you can definitely do a security group, right? You cannot directly connect with EC2. You will have to leverage like ELB or something, right? Like I mentioned, right, you have to use load balancers. That way your EC2 instance, your on-prem, the AWS earlier old EC2 instances can use a URL or something, ALB URL, and then connect to it. You can do that.
Okay. Yeah. And next question is, someone have shared that a certified Kubernetes security specialist. So before doing this, do we need to do any other CKA, CKAD?
I don't know. It's a new certification.
CK is mandatory for anyone to get CKS. So you need to first complete CK, have the certificate, and then you can attempt for CKS exam.
Okay. Yeah. Thank you.
Cool.
Suresh, do you have a question? Suresh, if you're speaking, we can't hear you. Fine. I think I think Ajay has already shared, how to reach him, information about himself, and Nabarun as well. Right, you can find him around. Also, if you have any questions around the community, the Kubernetes community, how to get involved with upstream projects, and how to make code contributions to Kubernetes or anything of that sort, Nabarun is your guy. You can just ask Nabarun. So yeah, I think that brings us to the end of this meetup, right? In any case, if you have any more questions, you can always, hit up the speakers. They have shared their information, and we'll be tweeting out their slides. We'll be putting up their slides onto our meetup page as well. And we will, you can just, hit them up offline as well. And I'm sure that they wouldn't mind, taking your questions offline as well, right? So just give me a second. So that brings us to the end. So I would like to, first of all, thank the speakers for, spending this weekend, a good part of their weekend with us. I know, with all the time that we spend in front of the screens these days, it's, 1 more hour feels like a lot more. So thank you, Ajay. Riyaz is not there with us, but thank you, Riyaz, Ajay, and Savita for spending, their weekend with us, and helping the beginners, the absolute beginners, come up to speed with, what's Kubernetes and how does it add value to you? Why do we need Kubernetes? Answering a few basic questions like these, right? So thank you so much, Ajay and Savita and Riyaz.
Thank you.
I would also like to thank a few folks who were around, helping people out, answering their questions constantly during the session, right? So I would like to thank Suraj and Nabarun for doing that. I could see that they were engaging with everyone on the chat and answering the questions. So thank you so much for that. I'd also like to thank everyone who attended this meetup, because it's not possible doing these meetups successfully without the audience. So thank you so much, all of you, for showing up on a weekend and spending this time learning Kubernetes with us. Also, we do this every meetup. So there's a Kubernetes Slack. So it's on slack.k8s.io, right? So I have just pinged it on the chat. So there's a Kubernetes public Slack channel that you can join, and you'll find most of us there. I'm sure Savita, Ajay, Nabarun, Suraj, all of us are there. And Nabarun just pinged the, India. There are a few India-specific channels as well where you can find us. So most of the speakers and almost all of us are over there. You can engage with us there on the Kubernetes Slack. There are a lot of other folks, a lot of upstream contributors to Kubernetes from India as well. So they are there to answer your questions and help you in this journey. Also, if you have certain talks, right? So we do this meetup every month, once every month, and we always look forward to receiving talk proposals from people like you, right? A lot of us started as attendees of the meetup as well, and then we started taking on bigger responsibilities. We spoke in certain sessions, and we started engaging with the community more. So it's about you. You can, if you have any talks that you want to submit to us, or you want to talk about certain things in the upcoming meetups, you're always welcome. You can ping me or Suraj or any of us offline, and we present in one of the upcoming meetups as well, right? So yeah, so that's about it. Thank you for joining us today, and you can feel free to drop off now. Yeah, I'll be ending this meeting right at 6 o'clock, 3 minutes from now. Yeah. If anyone has anything to add, you can go ahead right now. I have allowed participants to unmute themselves right now. I think right now we can safely do that. Also, apologies for the few hiccups at the start. We will try to do better from next time. This is the second time that we are doing it on Zoom, so we were caught off guard. So we'll take better measures to deal with spam from the next time. Yeah.
Well, thank you, Prakash.
Thank you.
Thank you, Ajay.
Thank you, everyone. Yep.
See you guys. Have a good weekend.
Have a good weekend. Yep.
I'll give you your weekend back. Bye.
Yep. Bye-bye. See you guys.